Hello everyone, good morning. It's our honor and pleasure to welcome all of you to this second edition of Industry Academia Conclave. So a very warm welcome this rainy morning to all people who are based out of Palakkad. We've been witnessing torrential rains this very morning. Here I go with the welcome address. Heraclitus once said, "No man can ever step into the same river twice, for it's not the same river and he is not the same man." If we were to draw a semblance to these changing times, then we could effortlessly say that the river or the very environment in which we operated has changed entirely. For instance, we were at this very day last year chirpily running around fixing errands to have a seamless experience for our industry delegates at our campus for IAC 2019. We had several days and hours of hands-on preparation, which allowed a brilliant culmination of the event. However, the edition 2 of IAC was markedly different. We had Google Meet call on event, Google Meet call on schedule, Zoom call on managing technology, and the like. That was about it. Although the length and breadth of our tasks remained the same, the familiar structure in which we operated is no longer existent. So during the times of the external change, we have all changed as humans by bringing and sharpening the one tool of adaptivity which we have been endowed with. Maybe a pandemic was good enough to also bring out the umpteen possibilities of looking at our days and lives differently. Regardless of the change, and in the midst of this now familiar pattern, here we are on a brand new day with a bunch of brand new minds to deliberate on something that is absolutely ours and unique. Although separated by distances, we have come together believing in the vigor that unites all of us. That is the intent of collaborative thinking. Maybe uncertainty gave us a wide compass of possibilities, which began with empowering every stakeholder to act as catalysts to accelerate transformation. Maybe uncertainty gave that untiring belief in each of our thematic interests to collaborate and innovate. Collaboration to foster a culture that fuels this transformation in a volatile world like ours. Hence, we are by definition, all of us, a community of idealists who have gathered here, thinking beyond the present and the status quo to imagine how and when things could be different, could be otherwise. Thus, we make this conclave even more unique is the art of discovering something new together. An act we call co-creation is the catalyst that transforms learning into a launchpad for developing winning systems. And of course, people who gather here are all the seekers and generators of knowledge, and we share a special connection across time and space. So here we are bringing in people, ideas, and innovation, ready to be etched and forged in directions that would mean wonders to the institution, the industry that you represent, as well as for the world outside. With this note, let me move on to extend our hearty welcome to one and all who have made it to this morning. I, on behalf of the organizing team, extend good wishes to the industry delegates who have set aside their time to join us at the conclave. I also welcome each and everyone who has logged into the conclave and have extended their eagerness in contributing to the larger cause of collaborative thinking. I particularly welcome the students and research fraternity of IIT Palakkad. I sincerely hope and believe that we have a very productive day ahead. It brings me honor and great pride in welcoming our leader and our mentor, Professor P.V. Sunil Kumar, to our midst. It would be rather audacious to put in place a befitting introduction to our director. However, here I attempt a brief one. Professor P.V. Sunil Kumar is he is a PhD from the Raman Research Institute, Bangalore. After postdoctoral research at the Institute of Mathematical Sciences, Chennai, and the Max Planck Institute for Colloids and Interfaces, Germany, he joined the faculty of the Physics Department of IIT Madras in 1999, where he is now a professor. At IIT Madras, he was the head of the High Performance Computing Facility during 2007 to 2014 and head of the Physics Department from 2012 to 2015. He was the head Department of Physics, IIT Hyderabad during 2009 to 2012. Currently, he is the director of IIT Palakkad. His current research interests are in soft condensed matter and biological physics. He has authored numerous papers and book chapters on a variety of topics such as liquid crystals, fluid membranes, polymers and physics of active matter, and is engaged in a vibrant program of research in these areas. He is a fellow of the Indian Academy of Sciences, Bengaluru, and was an associate member of the Center for Biomembrane Physics at the University of Southern Denmark. He was awarded the visiting professor position of the Finnish Academy of Science in 2006 and the JSPS visiting professorship for research in Japan in 2015. He is a recipient of the Professor M.B. Piley Award for the Distinguished Academician of India in 2019, instituted by the Cochin University of Science and Technology. I welcome Professor Sunil Kumar for the presidential address.
Good morning, everybody, and dear students, the delegates of this meeting, and my faculty colleagues and other colleagues. Welcome to this second edition of Industry Academia Conclave at IIT Palakkad. So I thought I should start with a brief on IIT Palakkad itself. And since many of the delegates here from outside maybe new, some of you might have participated in the last year meeting, but many of you may be new. So I thought I just give you an update on what we are now, this institute, and before I go into other matter. Let me share the screen and present you. Sorry, I can share the screen, right?
Yes, sir. Yes, sir.
I hope you can see my screen.
Yes, sir.
Oh, this is not functioning. Yeah. So welcome to the institute once again. So we are an institute. We started in 2015. So we are actually just in the fifth year. We just finished 5 years. We are in the sixth year now. Okay. So currently we have, just give you some statistics on the number of students we have. Okay, and so we have a total about 742 students. We are actually supposed to go to 1,000 when the admission finished this year. Unfortunately, due to many reasons, admissions have been delayed. So we actually one batch short right now. We should have had the first year students and the first year MTech students and the new PhD students, etc., in place now. But all that would be happening from September onwards, August and September onwards. It will be happening. So currently we have 742 students in the institute and a faculty strength of 91. So the most important thing which I want which is relevant to this conclave would be what has happened in the last year during our placement and internship. As we can see that we had 82 students registered for placement. We were able to place 74 thanks to extremely good work done by the Career Development Center. It's 74 people who were able to place. The most important thing is to say that like about 25 to 26% of them are actually in core engineering. Yeah, I think that is commendable for us. Of course, 50% goes into IT, which is true everywhere. Okay, we were actually more interested in seeing how this core engineering sector grow as we go. So this will be one of our focus thing in the coming years too. Even on the internship side, you can see that we have 43% of students going to actually doing core engineering, and 34% going to IT sector, and about 18% going to research internships in other institutes. And so about the new programs which we started this coming year, the last year, so we have now started an MTech in data science, which is again admissions are just completing, and an MTech system on chip design, and MTech in computing and mathematics, and MTech in power systems and electronics, and MSc in mathematics. So now we have actually 6 MTech programs and 3 MSc programs in the master's level, and 4 BTech programs, and 4 BTech programs in core engineering branches. Actually, I'm happy to present this because in the last industry conclave, we had actually discussed starting new MTech programs and the possibility of doing that. We actually managed to do that this year. Okay. And now we have this 4 more MTech programs and 1 more MSc program. And we also, during this year, we actually kind of defined our thrust areas for research, and which is it's listed here. We have basically health and biomedical engineering, manufacturing and materials, where we also have a MTech program, and water resources and hydrology, geotechnical engineering. Again, we have an MTech program there, and we'll have an ecology program, which is we're going to start, and agricultural engineering and food science, and data science and artificial intelligence. And again, we know that we have an MTech program there. Okay, cyber physical systems. Again, if you look at system on chip designs, will be actually coupled to this, and then cyber security. So we have actually aligned all some of our MTech programs also with our thrust areas for research, and we hope that will actually give the students a upper hand in it. We also have a few research initiatives which I would like to report to you. And one is on the we are starting a technology incubation hub on intelligent collaborative systems. This has been awarded to IIT Palakkad recently, 2 3 weeks back. Okay, it's a 100 crore facility which will be actually hosted in IIT Palakkad. This is a facility which will be in collaboration with IIT Bombay and IIT Kanpur.
I don't see I like mullet in your contacts. Perhaps you meant one of these 25.
Then we're also starting an incubation center here, a startup and incubation center at IIT Palakkad. This is also in the final stages now. Okay, and the goal of this is to actually, take up disruptive
Here's the
technology
contact
solutions.
info for Palakkad.
And I'm sorry, this. Uh, Disruptive technologies and incubate them and translate. We take ideas, from the students and from the faculty, and also from people from outside, and incubate it at the center and take it to the next level. And some of the facilities we'll offer in this would be, the usual thing, like we'll have basically an mentorship and experts from in the institute. Okay, and we'll make accessible just our lab and other facilities in the institute. So this will be actually set up as a Section 8 company, and we will have a core team which is actually mentoring it, and we'll also have consultants from outside to do that. We are actually in the advanced stages of doing this. Okay, we're just finalizing the funding for it, and looking to start in a couple of months from now. So this will be a major initiative here, apart from the TIH which we are going to have. We also have now a set of central research facilities. Okay, again, our ideas were always to kind of get all the research facilities into certain centers. Okay, and so that we can actually support it and give it necessary funding and administrative support, and also technical manpower. And with this idea, we have actually started a few research facilities, basically the instrumental facilities, okay, which will be available to all researchers. And the researchers outside also could be able to use it. Okay. And so that this is, so with that idea, we actually set up these facilities. We are making it available to people outside industries and other institutes, etc., with a kind of a graded graded charge for the use of the facilities. And so a couple of them which we are already set up is, one is a central instrumentation facility and central micro and nano fabrication facility, which is a host of a variety of equipments. We spent over 30 crores setting up this up in the initial stages. Okay, this will be actually an ongoing process. It will continue to expand and add more and more equipments and fabrication facilities into this, and we will be upgrading them continuously. And we also have a materials and manufacturing facility here. Okay, again, our plan is to get state-of-the-art equipments for additive manufacturing and precision manufacturing, and make it available to industries around, and also to other students who want to do projects from other institutes and research institutes, etc. So we have, as part of that core facility for additive manufacturing, we actually have had a industry grade 3D metal printer. And if you have time, okay, sorry, this is an online thing. So next time when you visit the institute, you should be able to go and see these facilities. Now we have also started, apart from visiting of these facilities, we also started some research centers. And we will be actually adding more and more on this research centers. Again, the core idea here is to bring a group of people together and set up the facilities and have a core group working on a central theme, okay, and so that we'll be able to again provide better support from the institute, and also the institute will be get more visibility on a certain set of areas. And now the one which you have started now so far is three of them. That is Advanced VLSI System and Architecture Lab, and Computational Imaging, and this Physical and Chemical Biology Laboratory. These are the three centers which we have started, of which computational imaging is actually already made a significant progress. And so there the idea was actually to have sensing, imaging, and then accelerating. So they've been working on sensor array designs and computational software for design facility, computational software design facility, and accelerated hardware facility. And where this particular center has actually made already some news in the COVID research area. They have actually come up with an automated lung and ultrasound for COVID-19, and which has actually been now in the testing stages. So, and we also started, again, this was discussed in the last, I mentioned this in the last meeting when we had the industry conclave. Okay, we will be setting up this center, and we have started this center now, and Center for Research for Education in Data Science. Again, there is a whole set of departments which is involved in this. This is a transdisciplinary facility, and we have mechanical engineering, physics, chemistry, electrical engineering, and mathematics, and computer science and engineering, all participating in this thing. So this is something which goes from computer science to chemistry, okay, and biology. And in this under the center, we actually started a couple of initiatives already. Okay, so MTech program, I already said that we are already in the final stages of closing the admission, and we're starting with about 20 students in the MTech program, and we also have a set of research topics which is identified as a theme area, core areas in this, or the focus areas for the center. Okay, that doesn't mean that we're going to do only this, but this will be the focus areas to the center for the coming 5 years, which is on smart farming and water management, AI-based water management, and something on which is relevant today, that is immunizing the world against zoonotic epidemics and data science. So this is just to report you that we have done a set of COVID-19 projects in IIT Palakkad, starting from a ventilator design to modeling and simulation. We have set up a set of projects which actually all came from the faculty and the students and the staff involved in doing these projects, and it is all going in full swing now. In that connection, we are actually, in fact, one of the good things came out of this COVID-19 situation to our thing, whether we were actually able to make some immediate industry connection. And the institute has now actually signed up or made an MOU with Kanjipur Industries Forum and ITI Limited Palakkad and Sri Chitra Tirunal Institute of Medical Sciences and another startup company here called Cooper Medical Technology. And these MOUs were signed actually to take the products which have been designed, which have the designs which have been developed in the institute to the market. And we hope some of them will actually see the light of the day. And just to, before I close, I just want to update you about also for our institute, the other part of the institute, that is about the physical infrastructure in terms of buildings, etc. You can see this is our master plan, and we are on this side of the campus, which is what we call as the Nila campus. Actually, I'm speaking from this particular campus now, and sitting in one of the buildings here. And this side of what you see on the right side is our main campus, where the construction has just begun. And the construction actually began in March, and we've been hampered by the COVID lockdown, so it's been going a bit slow. But I hope that it will soon pick up its momentum, and we will be able to finish whatever we have reconstructed in this part. This master plan is for the entire institute, which may take about 60 years to build. Okay, we want the set of buildings we are making here in this area. We hope it will be ready in 2 years, including some hostels and some faculty residences. Okay, this is an academic zone, and that is a recreational zone, and that is a residential hostel zone, and we have a residential zone here. And everywhere we'll have a few buildings coming up for the first phase. And as Nilla campus, I told you, now this is where I'm right now speaking to you from. This is a completed thing, and this set of buildings have been completed. We have hostels there, and we have some academic buildings here, and we have a big auditorium, which is now ready for use. So that's update I wanted to give you, and this is the status of the main campus. We have made some roads and some water bodies. Okay, and the construction has actually, this is a little bit old. The construction has now begun in this area, and we hope that in 2 years we'll have. So that's all I wanted to tell you in this in the update. And regarding this meeting, and let me just stop sharing this. Yeah. Okay. So regarding this industry academia conclave, it is extremely important for the institute to have this as a regular program, and we hope that we will be able to do this in more often than once a year. Right now we're doing this once a year, but we would actually like to do this, at least twice. Okay, one with a general meeting like this, and the second one a little more thematic, and for each core engineering branch, and or a core topic which we can take. Since most of the things today are interdisciplinary, okay, we could actually branch into some themes and have some thematic meetings too. And we hope we'll be able to do that. This year, actually, we wanted to start something like that, but due to the situation, we were not able to organize it in that fashion. But we hope that we will be able to do that. So, okay, with this things, I welcome all of you once again, all industry delegates and all participants, and all students especially. Okay, and hope that you have a good interaction, more than just presenting something and meeting people on the thing. It's most important is to have that continued interaction, and I hope this will seed that continued interaction, and we will have many projects and which we will do together. Okay. Welcome all of you. Thank you.
Thank you so much, sir. It has been a pleasure to always listen to you and also to get the update on our own institution in the most eloquent manner about where we are and what is our plan ahead. So thank you so much for bringing the vision of IIT Palakkad also in terms of the IAC 2.0 also in place for the participants to listen to. It has been always a pleasure to have you with us, sir. Thank you. At this point, I would like to just share a note to the participants. In case you have any query, please start placing them in the chat box. The chat has been enabled for all of you. So kindly start placing if you have any queries at the chat box. Next up, I welcome Ms. Anuradha Shankar, the Chief Innovation Officer of IIT Palakkad, to introduce you to the keynote speaker. Ms. Anuradha is an alumna of IIT Kharagpur who has had a long stint at the software industry for more than a decade. She has been associated with TCS and Citibank and brings with her the experience of running a center for science through hands-on experimentation for 12 plus years, thereby encouraging students to innovate. So I welcome Ms. Anuradha to take over.
Thank you, Soumya, for that introduction. It is my pleasure and to welcome Dr. K. Subramaniam, who is our keynote speaker for this morning. He is an alumni of IIT Madras and did his BTech there, went on to do his PhD from Cornell University, Ithaca, where he specialized in microelectrical mechanical systems, MEMS. And after that, he worked with GE Global Research, where he has been awarded many awards, notably the Hull Award for being the early career, The Hull Award was for his early career innovation, and later he got the Whitney Technical Achievement Award for being the most potential market changing project. He has been a Six Sigma black belt achiever, and he has plenty of publications and reports in his name. Currently, he is the executive director of Power Gears Limited of the R&D division, where they are doing many unique innovations and projects. So their idea is to showcase India's innovative side to the world. Over to Dr. Subramaniam.
Thank you, Anu, for the introduction. I hope the audio and video are both clear.
Yes, sir. Yes, sir.
So let me just share my screen and put up my presentation. Please let me know if you can see my screen.
Yes, sir.
Yes, so thank you for inviting me and thank you for the introduction as well. I just heard the director's speech over the last 15 minutes, and very proud moment being an alumnus of IIT Madras to see so many new IITs come up. And I guess it's not new anymore, it's 5 years old now, 5 years young, I should say. So, and being a native of Palakkad myself, it is more of an honor to hear all of the new infrastructure that's coming up. So today I'm going to talk about the topic of performing research of relevance to the real world in educational institutions. And I know I am preaching to the experts here, but I'm going to go out on a limb. Giving advice is easy, but through all the experiences that I've had in terms of performing research and development in various places around the world, I'm going to share some of my thoughts on what it takes to make that connect between academia and industry. So I am actually seeing a very empty classroom behind Anu's, where Anu is sitting today, and so I guess that is a reflection of the times. So we will fill the minds today if we can't fill the classrooms. So I would like this to be as interactive as possible, this lecture. I know this cannot be interactive to beyond a point because we are all online, but to the extent possible, I would encourage questions and answers during this session. As the director also mentioned, it's more important rather than to interact rather than just hear and see slide after slide. So with that in mind, I would like to get started. So I know Anu did a quick introduction, and I will just add to that a little bit. This is not intended to talk about myself, but more to kind of showcase the breadth of experience, right? Which I think will bring some credibility to this talk. So after IIT Madras, I actually went to Cornell for my PhD, as Anu had mentioned. After Cornell, I interestingly branched off into a career in consulting. I joined McKinsey and Company in the US for a while. And then I decided my heart was in research. And then I came back to research. I was actually a postdoc at the University of California. And after that, I was working for GE, global research in the US. And that was especially a very interesting time because I don't know how many of you know a lot about GE or General Electric. GE is, of course, the company that was founded by Thomas Alva Edison after he invented the light bulb. And he needed a company to market that light bulb. And he realized, of course, that there are no power connections to people's homes. So he started a company which provided the power lines first, and then he started manufacturing the bulb and selling the bulb. So the company, of course, is a couple of centuries old, and at least at the time that I was working for GE, which is more than 10 years ago, in the US, GE was a very diverse company at that time. And I'll explain why I'm talking about this. So GE was into so many different areas. They were into medical equipment, they were into aircraft engines, they were into industrial systems, they were into corporate finance, into credit cards and stuff like that. They were into plastics, they were into movies, for instance. The King Kong movie was actually made by GE. They actually owned Universal Studios at that time, which was later sold off. So very, very diverse environment. So for a scientist like me at that time, sitting in what was called the corporate research lab, right now called the Global Research Center. So this was like a central facility where all of these business units, right, as I said, aircraft engines or medical equipment, etc., all of these would kind of come to us and tell us what their vision is in terms of what technologies, what new innovative ideas they want to launch in the future. So us being scientists would take those vision statements, and then we would figure out what research needs to be done to hit that vision. Right. So that was a very enriching environment where we used to perform applied industrial R&D. And through this lecture, my goal is to explain more and more as to what, at least in my mind, is applied industrial R&D, so that we can make a better connect to the kind of R&D that happens in academic institutions. So I spent a lot of time at GE. I ran a very large project which spanned multiple countries. Specifically, this was a project that deals with using the field of micro and nanotechnology and applying it to the area of high power. And now this is a very funny marriage, because micro and nanotechnology is about small things and high power is usually about big things. So the achievement in part was to literally show that for high power, it actually helps to go to very small things, right? So that's a separate lecture, but hopefully that's just a teaser, and then you can just dwell on it a little bit. So this project was actually spun out of a company. It is called Menlo Micro. You can feel free to Google it. MENLO, Menlo Micro, which is talking about the applications of these devices, first in communications and then later on in high power. So Menlo, in honor of Menlo Park, New Jersey, where Thomas Alva Edison started his first research lab. So after that, of course, I had a lot of successful R&D projects, but more importantly, taking research and development to real product, which is not a joke. The latter half of R&D is as important as the R&D itself, interestingly. As part of that, many issued patents, then came back to India in 2010, joined this company called Power Gear, where I initially deliberately spent a lot of time in production and supply chain, because that is pretty much real world, right? Because a lot of companies ultimately have to go into production. And when you say production, you have to manage supply chain, which means everything that feeds into the production. Right. So this is my brief history. And as you can see, it has touched upon various different aspects of industrial jobs, right? And this has been the foundation of what I'm doing now, where I have set up what is possibly India's first contract R&D institution, where within industry, we have a bunch of scientists and we become the extended research lab of other companies. So large and small, where if it's a large company, they may have a research lab internally, and then we become an extended facility for various reasons. They may need some more skills, they may need some more people, they may need some new projects done. For smaller companies, we become their entire research lab. So we have this model where we have essentially do outsourcing of research at the level, so outsourcing at the level of research, basically. So with that in mind, let me get to the meat of the talk. As I said, I'm preaching to the experts. I'm preaching to a bunch of IITians. So I'm going to, through a series of examples, try and showcase what industrial research and development means to me. And hopefully that can result in a better bridge between what the world wants and what premier institutions like IIT are doing and will do in the future. So I'm going to talk about the first mantra that is key, right? So the first mantra is think in reverse. Okay, so it is exactly what it means. So in industry, and again, correct me if I'm wrong, but in academia, a lot of research is done through inspiration, where for a student or for a faculty member or for a research staff, there is a new idea that comes to mind, and the person obtains funding, puts together people, and then performs research and innovates along those lines. Which is very good, which is also required. But the catch with doing it this way is that once you finish the research, you're not sure if the industry is going to pick it up, and you're not sure if there is a real application waiting. So the research may be fantastic. You may get publications out of it, which is of course important. But is the research going to see the light of day is a key question that happens if you think this way. So if you think in reverse, which is exactly what we do in industry, we don't kind of feed our aspirations in terms of new ideas that much. What we do is we look for the market first. Even before we come up with an idea, even before we have an innovation happening, we look at the market first. So when I say market, we look for an application, right? So we look to see if the market is, if the world is desperately looking for a solution to some key problem, right? So starting from that, we work backwards to see now if there is a certain problem that the world is looking for, and how do you work backwards to define a research program to solve that problem. So that focuses what innovation happens. And of course, at the heart of this, once you define that kind of a program, then there is a lot of both fundamental science and also applied engineering that happens to hit that requirement. And once we hit that requirement, the application, the beauty is that the application is already there. So there is no reason to complain that industry isn't picking it up, that there is no application for this technology. So because you started from the application, you started from the requirement, you started from the market in the first place. So this is how we work. There are of course pluses and minuses, but this is how industry thinks. And I'm going to illustrate this through a very simple example to show you how an application question that is posed can boil down to an innovation question, and consequently how you can do some very fundamental science and eventually some engineering to hit that application and actually make a business out of it, right? So here in this example, we're talking about an application which is a very common application, where in almost any kind of electrical distribution system, whether it is wiring inside your home or wiring inside a factory or transmitting power from a power station across long distances, everything is done today using copper. So copper is the conductor of choice. Yes, aluminum is a close second, but the catch with aluminum is it is cheaper, but you have to use more of it to get the same resistance. So you kind of even out in the end. Right. So it's a very simple question that is posed. Copper costs money in power distribution. Copper is not a cheap metal. It is fairly expensive. And to transmit power across short or long distances, anywhere you need copper. Right. So now how do you solve this problem that you want to use less copper and still transmit all that power? Right. So this is a classic application problem that will be posed by an end user in industry who wants to innovate and who wants to launch a new technology which tries and solves this problem. And again, it sounds crazy because it sounds like a problem that you cannot solve. It sounds like a very fundamental problem because obviously you need metal, you need metal to conduct electricity, and you need to, you can't really compromise on that, right? So the innovation question that is posed as a consequence of this is how much current can you carry through a piece of wire? It's a very fundamental question, right? And if you really think through it, you will realize that after everything that you learned in high school and your IIT coaching and your later on in IIT itself, sometimes we haven't asked ourselves these very fundamental questions. So if you go to the shop and if you ask for, let's say, a 5 amps piece of wire, the shopkeeper will intuitively give you a thin wire. If you go to the same shop and ask for a 15 amps piece of wire, the same shopkeeper will intuitively give you a fatter wire, a wire with a higher cross section. So intuitively, it makes sense to the shopkeeper, to you also. And we probably haven't thought twice about this, right? So if you really go down to the fundamentals, and that's where the innovation comes, the question that you pose, as is mentioned here, is there really a correlation between the cross-sectional area of the wire and how much current you can send through it? So the answer is not a straight yes. Let me explain. Normally, if this were an auditorium kind of talk, I would have posed this question to the audience, but let me answer this myself. It turns out that there is no direct correlation between how much current you can carry through a piece of metal and how big or how fat that wire is in terms of cross-sectional area. In fact, and this is a very interesting number that you could take away from this talk, it turns out that the theoretical current density that you can push through metal is about 10 to the power of 7 amps per centimeter square, which is 10 million amps per square centimeter, which is a very high number. So this calculation is based on how many electrons are available and for carrying that current. So 10 million amps per square centimeter should mean that you should not need a fatter wire between 5 amps and 15 amps, which is pretty much in the noise when you're talking about numbers like 10 million. So what is it that determines how much current you can carry through a wire, right? So the actual answer turns out that it is actually not an electrical problem at all, because the electrical limit of current carrying is so high. It is actually purely a thermal problem. So it turns out that even through a 5 amps wire, what is conventionally rated as 5 amps, or even through something that is probably conventionally rated as 1 milliamp, for instance, to speak of an extreme case, you can carry hundreds of amps of current if you can manage the thermal situation. So what do I mean by saying that? It means that the wire is going to generate heat, right, when you carry current. So there is no material with zero resistance conventionally. So the wire is going to generate heat, and as long as you can thermally manage that heat and maintain the temperature of the wire, the amount of current that wire carries is not really a constraint, right? Which means through a very tiny wire, maybe the width of a human hair, you can probably carry amps, tens of amps, even hundreds of amps of current, as long as you can cool it. So this now spawns new engineering ideas, which is how do you maintain the temperature of the wire, right? Now it shifts the problem and allows you to innovate and truly solve this kind of an application. So it is very much possible that you can significantly reduce the amount of copper and still carry a lot of current. Yes, the cross-section matters to a point, because the cross-section tells you how much heat is generated in the first place. Bigger cross-section, less heat is generated. But it really does not tell you how much current the actual wire can carry. So I hope this little teaser kind of opens your eyes to some very fundamental problems that we have taken for granted and not quite thought about, right? And once you start thinking about it, then the innovation happens. But in this example, we have started from the application and we have worked backwards to define what fundamental innovation can happen. So as soon as you innovate, there is the application waiting for you. you can create wires, which are very fundamental to the electrical industry, which are far cheaper than what wires cost today, because you can use less copper. So with that, let me go to the next slide. This is another mantra in industrial R&D thinking. We always think very multidisciplinary. This is a very obvious statement in hindsight, but I want to emphasize on it because it is easier said than done. And again, it's not a criticism, but it's more of a constructive suggestion that though a lot of IITs have a lot of different departments, so they have many, many disciplines internally, it's not easy, to be frank, to have faculty and students across different departments collaborating and truly working together. So that is still a challenge, right? It happens in some cases, but that is still a challenge. So this was a problem that we worked on. There is a device called a PIG, P-I-G. It's an expansion for Pipeline Inspection Gadget. And it's a very big international problem on how do you use these kinds of devices to detect corrosion in pipes. And I'm talking about all kinds of pipes. These could be narrow water pipes. It could be huge, big, fat pipes which carry oil from country to country. There is an international problem where these pipes get corroded over time, and it costs billions of dollars to maintain these things. So detecting corrosion is just a big deal, period. So, and to solve a problem like this, right? Even though corrosion, the word corrosion sounds like it is an electrochemical process, of course it is. But to solve a problem like this, you need all of these skills which are written down in the bottom half of the slide, right? Electromagnetics, because you need to invent a detection system, you need to invent a sensor which is able to look at the corrosion, and corrosion is often hidden. It is not often visible. It is often hidden somewhere inside. So you will need to use a non-invasive penetrating method, which is where the electromagnetics likely comes in. Optics, because you may need infrared, you may need visual, visible wavelengths, all of that to detect corrosion and augment the signal that is coming from electromagnetics. You will need robotics. Why? Because you will need these devices to travel through those pipes. So these PIGs, pipeline inspection gadgets, literally travel through kilometers and kilometers of pipelines, continuously inspecting them and then coming back with data, right? And then of course you need electronics, because whatever data you read, it is not just, and these sensors may give you a very, very low kind of signal. So how do you filter noise? How do you figure out if it's really corrosion or if it's something else? So, and then how do you store data? How do you transmit it? All of that stuff comes in. And remember, most of these pipes are metallic, so wireless transmission will not work because of the Faraday cage effect. So very innovative stuff needs to be done in electronics as well. And controls, because you'll need feedback mechanisms. It is, you may be able to send these devices traveling through the pipes, but more importantly, they have to come out safely. They should not get stuck inside, which is where the controls become important. And then eventually system integration. This is something that is hugely underestimated in most cases, where all of these have to come together and work as one whole, which is not at all a simple thing to achieve, right? So this explains how industry thinks in a very multidisciplinary fashion. So right from the start of a research project, it is a team of scientists, team of researchers who are skilled in very many different things. And you may have heard the saying that innovation happens at the intersection of disciplines. So it is true that when people, in this case, for example, robotics or controls and optics come together and sit in one place, is when new sparks will fly and new innovations will come up. So let me go to the next slide. I have very few slides in this presentation. I wanted to do more talking and more examples. So third mantra is, how do you make the innovation very product oriented, right? Partly covered in the first mantra, where you think reverse from the product and then come to the technology. But again, there are other facets which I wanted to highlight here. So there was an application for ISRO As you may have heard, a few years ago, there was a satellite launch that failed where everything was fine except the satellite failed to detach from the spacecraft. And how does this detachment work? Many ways to do it. One key way is it is literally tethered to the spacecraft using a rope, right? As simple as a rope. And if this rope needs to be cut off, and specifically in this example, it was cut off using a micro heater, which means that literally you're burning off the rope and the tether from the satellite to the spacecraft is cut at the right time, right? And if you look at this application, the product thinking becomes extremely important. And what do I mean by product thinking is stuff beyond what you may think of as just the technology, right? Which is cost in some cases, it is manufacturability in some cases. In this case, it is reliability, which is the science of how things fail. So in this kind of an example, literally listing down every possible way that this could fail, right? So there is a process called FMEA, failure mode effects analysis, which is an established process to rank failures and figure out which failures are more interesting. And there is a line there saying custom alt. ALT stands for accelerated life test, which means that if this has to live a certain life, you invent a certain test which accelerates that life, which means you test it for a week and it's equivalent to, let's say, 10 years of life in the field. So in this application, this micro heater tether combination has to be essentially, it has to live an infinite life until that one time that it has to burn off and separate. So that reliability is almost also another infinite quantity here because it only has to work once and it absolutely has to work in that situation, right? So this is kind of a facet of product thinking where you have to take into account factors like reliability, factors like cost, factors like packaging, factors like manufacturability right in the early research stage. Otherwise, you're doomed to fail. Pretty much you're doomed to fail later on. Because if all of these things are an afterthought, if you think that let me invent the technology and then let me worry about these things, then there is a very, very high probability that you will not make it to product. Okay. So one more mantra, actually it's a bunch of things, is the business case, right? So, and these things are also important and again, not to be an afterthought, have to be decided early on. Is first thing is the patent landscape, because it's very, very possible that you may be doing what has already been invented. You may be reinventing the wheel, as the saying goes. So it is important to study the patent landscape. Who else has patented in the same area? And patent landscape works both ways. It tells you what other people have done. It also tells you what other people have not done, which is called a white space in patenting, where it tells you, okay, here is one open space which has not been patented. So let me innovate intentionally in that space, right? Third one is voice of customer. So one very, very clear directive in industrial research is don't assume what the customer wants. Always go directly to the customer, ask him or her what they want in the product. And again, this customer may be a normal human being off the street, or it may be a business which is launching a new technology. So customer means various things to various people, but the voice of that customer, what that person wants in this new technology is critical. And finally, timelines and deliverables, which is again easier said than done, because in research people tend to think that people have any amount of time, but it is really not true. Research, even though it is vague and unknown, needs to be done to very clear timelines, right? So with this, I just have a couple of 2-3 slides to close. So the technology ecosystem, right? So I'm trying to put all of this together and try to bring it to what we think is required to affect real R&D, right? So clearly academia is a big part of this because that is where we all came from and we still have ties to academia. So government R&D organizations are important. Industry's own internal captive research is also important. A lot of industry has that. They have their research that they do only for themselves. But right in the middle of this is where we are as a company, where industry R&D providers, which is also called contract research by some people, where we work with academia, we work with government organizations, we work with the industry's own research labs, and as I said, become the extended research facility of some of these people. So we try and bring all of this together, put an industrial twist on it, and make it something that is much better packaged in what we call a by industry for industry offering. So industry is very comfortable working with other industry, and we try and exploit that psychological feeling and literally put in all of these mantras that you kind of saw early on, and literally implement it practically to deliver real research, right? And on the right side, of course, are the consumers of R&D, people who use the R&D, which is industry and government. And on the middle, on that red line, you see kind of services which facilitate incubation centers, research parks, and auxiliary services like patent lawyers, stuff like that, right? And in this spirit, we ourselves have an MOU with IIT Madras where we do joint research offerings, because a combination of industry and academic folks offering R&D to either industry or government is actually a very attractive proposition, and it significantly increases the probability that the R&D will be successful. So I won't go through this in too much detail. This is just the areas that we work on. Broadly speaking, electronics, sensors, optics, materials, chemicals, and power. So these are all offerings. So very interestingly, even these skills were created based on where the market was asking for these skills. So we don't have, like an IIT, we don't have the luxury of having all departments permanently stationed. So we have to be market oriented even in the kind of people we hire. So whatever projects the market is asking for is where we have to hire. And the combinations of these skills will map into the markets shown on the right side. So we are into many of these applications in terms of providing innovation and being the extended research lab of companies in these areas. Okay, so this is a quick summary, and then I just have one more slide. There are major gaps. It's a fact. There are major gaps between academic and real world R&D. But the good news is, I think once we get honest with ourselves and say that, okay, we admit these are the gaps, then these gaps can be bridged, right? There's no magic to it. It can easily be bridged. And I think in one simple sentence, the way to bridge these gaps is collaborative research, right? And when I say collaborative research, I am not talking about what the government thinks of today as collaborative research. I'm being very honest here. Today, the collaborative research ideas are primarily circling around academic institutions doing the research and industry cost sharing the research, which still assumes that industry is the consumer of research and academia is the doer of research, which is only partly true. When I say collaborative research, I'm talking about from day one of a research project, industrial teams, academic teams, if required, government teams, literally working together on the innovative aspects. So a team that includes all of these people working together from day one, and that is the only thing that can increase the probability that this research will see the light of day, right? So I will end with one more teaser, and this is something for you to take away, which hopefully encapsulates everything, all these mantras that we have discussed in the previous slide. I have many teasers like these, but I just wanted to choose a couple for this talk, which I think drives home the point. Everybody knows that electric vehicles are a big deal these days. And the biggest issue, the single biggest issue, if you think about it, is how do you get a better mileage or a larger range in electric vehicles. So petrol vehicles, diesel vehicles can travel several hundred kilometers when you fill the tank, but electric vehicles, the battery technology is still far behind. There is a major issue with traveling several hundred kilometers in a single charge. Today, most average vehicles are rated for 80 to 100 kilometers. per charge, which is far behind IC engines. Maybe a few more exotic ones can give you a little more range, but it's still far behind IC engines, right? So how do you get better mileage? And this is a very application kind of question, right? And this, and if whoever solves this will be a winner in the market, will be able to sell much better electric vehicles. All of that will be a big deal, right? So to solve this, again, normally I would have posed this question to the audience and gotten some answers, but let me give you one possible solution myself. So the challenge here is keep the same battery. I don't want to put a bigger battery. I still want a much bigger travel range out of the same vehicle. So the answer to this in very, very simple terms comes from what you learned in high school, which is Newton's second law. Force equals mass times acceleration, F equal to ma, right? So if you think about it, there are only two quantities in that equation. One is mass, the other is acceleration. And force times distance is work done, which all of you know. And work done is the energy that you need from a battery, right? So work done is how much energy the battery has to be rated for. And work done is force times distance, force is mass times acceleration. So no more equations, right? So there are two things, M and A, right? So M, of course, is a key parameter. The lighter the vehicle is, you can actually get a much better mileage. So in hindsight, it's, I think, obvious, because, and if we concentrate on making the vehicle lighter, better materials, right? Lighter in so many ways, right? Motor has to be lighter, battery has to be lighter, vehicle itself has to be lighter. So all of that will reduce the mass, the M term. The other term is, I think, more important in my opinion and less obvious. Even though all of you implicitly know what that means, practically what does that mean, right? The other term is acceleration. So what that is telling you literally is that, let's say all of you are in Palakkad, right? So you want to travel from Palakkad to, let's say, Chennai, which is probably 500, 600 kilometers, give or take, right? What that equation is telling you is you can literally accelerate in Palakkad from 0 to, let's say, 80 kilometers per hour, 100 kilometers per hour. And if you maintain the speed without accelerating at all, you should be able to reach Chennai with no additional battery drop, right? That is what that equation is telling you, right? Again, I'm ignoring friction and air resistance for a moment to keep this problem simple. So let me repeat that. You can accelerate, which will take you 30 seconds max. And during acceleration, you will consume energy because there is a force when acceleration is there. And force time distance is the amount of energy you consume. And that distance is the distance through which you accelerate. It is not the distance from Palakkad to Chennai, right? So you only consume energy during that first 30 seconds when you accelerate. After that, you can cruise at a constant velocity without consuming any further energy at all, right? So the notion that a bigger battery will get you more mileage or more range is actually complete nonsense, because the capacity of the battery has nothing to do with the actual total distance you travel. It is only related to the mass and the acceleration, right? So if you now think of this problem differently, where you design electronics for the vehicle, which limits the acceleration, which regenerates braking power, feeds it back into acceleration, which you have to do again after braking, all of that, then that alone will significantly increase the range of your battery, right? I hope I'm making sense here. So what I'm trying to say is, working on the acceleration, we're working to limit the M term and the A term, will essentially limit the force and the distance through which the force is acting. Reduce the amount of energy that is required, and hence, therefore, reduce the amount of battery. In other words, with the same battery, you should be able to travel a lot longer, right? So I just wanted to throw this out there. It's now that I've said it, I'm sure it's very obvious. But this is what innovation is. It doesn't have to be very complicated. It can be fairly simple. But it has to be multidisciplinary, it has to be application driven, it has to be product oriented for it to see the light of day and for it to truly work, right? And as I have put in the bottom, feel free to contact me. I really enjoy working with faculty and startup companies. I do work with many people for mentoring startups and even academic research projects towards very successful research and business results, right? So this is something that should work out mutually, and it should be a great mutual collaboration, and it's something that I really enjoy doing. So with that in mind, let me close this talk and let me open up the floor for questions if we have time for that. And back to Anu and Soumya.
Yeah, thank you, Dr. Subramaniam. We do have a question. Some students think they have problems which they want to solve, but they worry they do not have enough skills to attack the problem. How to tackle this worry or fear?
So I think a very simple, straight answer is to form a team, right? So nobody has the skills to solve a problem. I don't, you don't, no individual does. And I think gone are the days where a single individual can make things happen. I mean, I know I gave the example of Thomas Alva Edison. Maybe 200 years ago, as a single person, he could invent a light bulb. So today, to invent something like that, I think you need a team of half a dozen people. So don't be shy of forming a team. Collaborations are the way to go, right? I don't think anyone should assume in the world today that they can do everything by themselves. That is just not going to work. So it is not wrong to collaborate. Let's all win together.
Wonderful. For want of time, we are going to stop there. But Dr. Subramaniam, you've done a great service to me because you've made my job really simple, and both in terms of teaching us 3 different ways of solving problems, think in reverse and the multidisciplinary and the third one. And also you've offered your services to be a mentor, which is what I was planning to ask you for later. But my job is much simpler now. Anyway, thank you very much.
No, there's a quick question which I can ask.
Sure.
Yeah, to Subramaniam. This is about this contracted research model which you very actively involved in. The research outcome, even when it is a directed research, is very uncertain, right? So how does the deliverables of this model work?
Yeah, it's a great question actually, and it's a very tough one to answer. The only rational answer I have for that is over time, we have been able to capitalize on the collective experience of our scientists to be able to very well estimate what would be a timeline and the probability of success before we start a project. The answer is a little vague and it needs to be tailored to the specific problem at hand, but we have gotten very good at this. So over time, as I said, when we get a new query, can you solve this? Here is a pressing problem, can you solve this? Right? There was a recent customer who came to us and said, can you count the number of cockroaches in a room? So this was a pest control company, obviously. And obviously, this is not something that's been done before. We, again, with our collective experience, right? We have people in so many different disciplines with so many different backgrounds that we could all come together, come up with a bunch of ideas, estimate the probabilities of which one would work, and write a proposal, of course, but also estimate what it takes to take, how much time it would take and how much effort it would take to literally realize this. So we have gotten good at it. I think it's just a question of experience.
Thank you. There are many other things I want to discuss with you, but maybe at some other time.
Great. Very much look forward to it. And hopefully we can meet in Palakkad at some point after the COVID situation improves.
Yeah. Thank you so much.
Definitely.
Thank you.
So thank you once again, Dr. Subramaniam. Over to Soumya.
Thank you so much, Dr. Subramaniam and Ms. Anuradha. This indeed has been a great way to set the tone for the conclave for the day. And we really are thankful for everybody who've been able to make it to this session at this point in time. It is understood that great research stands for truth, and the pursuit of truth demands perpetual effort. Truth has to be discovered, revealed through argument and experiment, tested on the anvil of opposing explanation and ideas. This is precisely the function of a great platform that we have today, where scholars in every field and discipline debate and marshal evidence in support of their innovation as they strive to understand and explain our problems. Thus, the next few hours would see the most exciting part of the conclave, which relies on listening and learning and thinking. The discipline-wise sessions, we hope, would bring to you the unique opportunity to deliberate and discuss the possibilities that lie in academia and in the industry. With this note, we close the inaugural session and break for a few minutes, following which the participants can join the respective discipline-wise interactions. We look forward to having you back at 13:20 hours for the next keynote address and panel discussion at this very same login ID. Have a very pleasant day ahead. Thank you so much for your participation. It has been a pleasure to be with all of you. This is Soumya signing off temporarily. Thank you. Hello, good afternoon, everyone. So, welcome back to the post-lunch session of Industry Academia Conclave 2.0. It has been an extremely enlightening session in the first half, is what we hear from the students and others who are giving us feedback. So, good afternoon, and here we are at the post-lunch session with our second keynote speaker for this afternoon, Mr. Nagaraja Prakasam, who has agreed to be with us despite his extremely hectic schedule. Mr. Prakasam, a small introduction about him. He is a versatile and passionate leader with over 27 years of global experience. As a full-time lead angel investor, he has led 15 deals, invested in 23 startups, serves 12 boards, seen 6 exits and 2 write-offs. He has spearheaded impact thinking in Indian Angel Network and co-founded IAN Impact. His personal mantra is startups should focus on India's strength, people, problems, tech. Believing in hands-on approach, he does Bharat Darshan traveling extensively into rural areas to perceive their needs firsthand. He's a much sought after name as a thought leader in impact space and is a motivational speaker who has inspired many students. He was featured by Forbes magazine as social investor, engineering social change. He's also a partner at Acumen, a New York-based $100 million impact venture fund, and served as an independent director in one of its portfolio company, Guardian, a microfinance venture working in water and sanitation. He is the founder chairman of Native Lead Foundation, which enables entrepreneurship in non-metros of Tamil Nadu with a vision to enable, nurture, incubate, invest, Native Angels. Native Leads has grown into 242 angels in Madurai, Trichy, Coimbatore, Erode, Tuticorin, Karur, Tirunelveli with 7 investments, touching about 120 startups in 37 colleges. He has replicated the native lead model in Malabar area of Kerala as My Zone or Malabar Angels. He wears many hats and serves as the advisor and mentor in residence at NSR Cell, IIM Bangalore, is part of the investment committee IIT Madras Incubator, is a mentor at CIIE, Indian Institute of Management, Ahmedabad, is a board member at Madurai Agro Business Incubator. I'm sure we have a lot to hear from Mr. Nagaraja Prakasam. He has also served as the president of Atlanta and Santiago chapters for the Association for India's Development. Earlier in his career, as president of CDC Software, he has engaged with South and South Asia markets, wherein he managed sales and India Engineering Excellence Center. He resides at Bengaluru and he has a BE degree from the Tyagaraja College of Engineering and an MBA degree from the Santiago Kensho State University, United States. Over to Mr. Nagaraja Prakasam, an esteemed keynote speaker for this afternoon. We welcome you to our midst, sir.
Great. I think hello to everyone. So, wish I could have connected person, but I think this crisis have turned everything upside down. But that's the good news as well, that we are able to connect with you, and I'm sure it saved a lot of time and effort as well. So, thanks for joining. I'm sure many of you are students. I think there is quite a bit of anxiety among all of you about wondering what is this, going to take us forward? And there is quite a lot of discussion happening around the country, around the world, a lot of messages going around. So I think it's good that your organization, your institution is organizing this to hear from people so that you get motivated and what can you do around what is happening now, right? Quickly about one is, unlike the other crises, I've seen a few in my career, which is around maybe financial crisis, not to this extent, right? So 97 Asian crisis or 2000 dot-com boom and burst, then Y2K problem. So we saw that computer ability not to hold 4 digits would probably, collapse the whole world. So like that, these are all this happened. But in this crisis, we know clearly who the enemy is, right? The moment we have a vaccine, and we should be able to get back to in action. But if it takes more time, that will have an impact around what are we doing economically. And spending time with the entrepreneur, right? Entrepreneurship is always about taking opportunities, right? So every crisis, every problem is an opportunity for you. And this is where, we encourage all the entrepreneurs that this crisis is an amazing opportunity. And I would like to keep it more interactive. So what I'll do is, after I spoke for a few minutes, I'm going to encourage all of you to ask questions in the chat box. Then we'll have Soumya just read it for me so that I can answer, so that we can make it more interactive, because you just came from lunch. I don't want you guys just put it on mute and doze off, right? Let's make it more interactive. You can ask me anything. So coming back, right? So this crisis is a fantastic opportunity. And in the initial days of the lockdown, I had a lot of sessions organized for entrepreneurs, what we are calling that as a pivot to adapt. So what does that mean is about this crisis provides an opportunity. How are you going to use this opportunity and turn around and create an opportunity for yourself, right? Like, for example, one of the entrepreneur who works in handlooms, and she was supplying handloom fabric to an apparel brand. And I don't think anybody's buying shirts that time. So immediately she switched to going to the same apparel manufacturer making masks. The second week of lockdown, she received 3 crore worth of order with 100% cash advance, right? So this is an ability of an entrepreneur converting problem into an opportunity. And then this is where she was able to do that very, very fast. Because in a crisis, we don't have time to think too much. If we keep talking, we keep analyzing, and we will miss the opportunity. So we need to move very, very fast in jumping and doing that, right? So we have another entrepreneur in Kolar in Karnataka. He was selling, providing inputs to farmers, company name Agrimitra. And so she will provide them, tractors for rental. He will provide them seed, all the inputs. So during the crisis, they saw that the supply chain is broken, right? Farmers are not able to market. So what they did then quickly is about transform their company into about selling their produce to the market. So today he's doing around 1 lakh a day, right? Because he's completely changed his model from providing inputs to farmers to helping farmers to sell their products. And he was able to move very, very fast in achieving that goal. And so he pivoted, right? So now when you pivot, you have an opportunity, right? One is whether you want to keep the pivot permanent, or when things get better, you want to go back to what your original vision. Depends on how do you evolve. You can think about, how do you want to take that forward, yeah? So like this, there are quite a lot of examples of people who pivoted. The second is about, so if you're not able to pivot, but you have a skill, can you repurpose your skill? So we have another entrepreneur who provides IoT services to farmers, created as sanitation tunnels, right? Using the same IoT sensor based. So repurpose your skill to the current need. So today, what is the current need? There are 3 areas which are very hot right now. Healthcare. The second is about essential. The third is technology, skilling, right? Because the first one is health. Still we don't have vaccine yet on the horizon, and anything we are able to find opportunities to work on. So last 2 weeks back, I saw a person from Madurai College. She's looking at a mushroom. It has a medicinal quality. It helps in cancer treatment. She's experimenting whether it can help with corona, right? So like this, there are people who are going deeper in addressing this crisis, especially in the health side, whether it is masks. People have created enough masks now. Now waste management of the mask is a problem. And can we make reusable masks that people make, how it has been reused? So those kind of stuff that we need to figure out how you can convert. Like for example, oxygen is big need right now. So can you make oxygen out of the air and create a ventilators, right? Or you have a very simple system for home quarantine. And yesterday, one of our startups sent me a shirt, and he said that this is coated with the nanoparticle. It's a virus repellent, right? So he got this technology from Israel, and he's just sent me the shirt. So like this, he was in the apparel industry, and nobody's going to buy a new shirt now. But you say that this is a virus repellent shirt, he can make it, right? So he made 2,000 of them and provided to the cops in Mumbai. So like this, people are repurposing their skills and figuring out what is the best way I can apply the skill to the current crisis. When you do that, there is immediate need. That's number one is healthcare. Number two is essentials. Right now, you need to eat. The lockdowns keep happening on and off, and people are not able to come out. At the same time, we need to move food to them. They don't need to starve. The essential could be a waste management, right? Because we continue to produce waste. If it is not discarded properly, then it can create more problems. So there's waste management is an essential now, right? So like this, people are in essential. That's a great opportunity. You saw that in the profile she mentioned about the Malabar Angels. So we funded our first investment in Malabar to a company named Farmers Fresh Zone by Pradeep. Pradeep is from Kodakara, Mala region, and he was in Cochin for an IT company. So he went back to his village and made the farmers grow vegetables again, because in Kerala, people get most of the vegetables comes from Tamil Nadu. He wanted to change it. So he created a farm to home model, worked with thousands of farmers in Kodakara, Mala region, and get these vegetables sold in Cochin. What is it different? So he has agripreneur, right? So they put all the inputs about what is growing. So if you walk into the Cochin store and take our crate and scan the tomato, it'll tell you where the tomato came from. The tomato came from Ranjit in Mala, and these are all the fertilizer he used. He used a traceability, right? So this farm to home. So before the crisis, and when he was pitching to an investor, VC, so they asked him a question that, are you a supply chain company or are you a consumer company? And he said, I'm a consumer company, but I'm helping the farmers with a strong supply chain. So I'm directly buying from the farmer and selling. And so the input is given to him was, it's confusing. But during the crisis, he grew 300%, right? Because the traditional supply chain is broken. What is the traditional supply chain? The farmer give it to a broker in his village. That broker take it to the local mandi. From that mandi, it come to the district level mandi, then go to a state level mandi. It changes 4 or 5 times before you get your tomato on your plate. But he was directly buying from the farmer. So with the mandis being closed during the crisis, right, nobody was able to move the vegetables. Where he was not relying on the mandis, he was directly getting from the farmer. So he was going with this organization without any supply problem. So with Safe to Eat, people sitting at home wanting to eat a healthy food, so they are buying more from him. So he grew 300% during the crisis. So this is where that opportunities are in essentials, right? If you're able to build a story and able to prove it. So the same investors who did not understand his model, now coming forward to invest in his company. Now in the education, the skills. So the skill side, there is quite a lot of opportunity because many of the schools are not operating. You see all your attending online your classes, and many of the schools are running online. But we are a poor country, right? With hardly 450 million have internet access. Maybe in 250 is proper internet. So that means around 1 billion people do not have access to internet. So how do we take the skilling to them? So online has a potential, but how can I take the online to people, right? Is it going to be beyond online? We have to think, is it going to be through the TV, or you're going to create devices that you can connect to a TV that can work, or you make the devices affordable to people? So there is an organization in Bangalore who is looking at a device to dream. They're asking people to donate all their old gadgets. So they repair and give it, donate to people who cannot afford these devices. So like this, there is, through internet, skilling is one major area. And without internet also, we have to innovate. Can we put a loudspeaker in the street and educate people, or through cable TVs? So there are a lot of opportunities available in skilling part. And on the skilling, another great opportunity, what I'm very happy about is there are a lot of people who went back from the cities, right? The rural reverse migration. So I won't call the word reverse migration, I call them city return. Okay, when I came back from US, people call me foreign return, right? So similarly, the people now leaving cities and calling this is a city disease and going back to villages, and they're going to think twice before they come back to the city. So this is a great potential for people on the grassroots, because the rural livelihood is lost. That's why we are losing all these productive youth to the cities, where they end up living in the slums. So now we have an opportunity to train them, upskill them, so that what they can do sitting at the village, and so they don't need to migrate, right? So there's a great number of opportunities available in that space as well, skilling the people who returned back from home. There are 11 million people have went back to their villages. And this is an official figure. So unofficially, there's going to be more numbers will be there. So like this, it's full of opportunities. As an entrepreneur, this is a great way to look at. As a student as well, it's a great opportunity, because the job opportunities may not be there, or like it was before, but problems are still there. Every problem is an opportunity. Every opportunity is a venture. So if you're able to create a venture while you're a student, this is the best time to create a venture while you're a student, because you don't have a much pressure on you. You can work on it while you are studying. By the time you graduate, you have a company which is profitable, and you don't have to worry about placements, right? So I'll just stop here and take some questions.
Sure, Mr. Prakasam. So we'll just wait for any questions that can come up in the chat box. There is one question from our Chief Innovation Officer. I think let's start off with Ms. Anuradha Shankar. So she has asked a question as to, when do you decide when to pivot to such kind of a change in your model? So if I probably understand the question correctly, when exactly is the time that you decide this kind of a change that you need to bring to your model? So that's the question, sir.
Yeah. Two way to look at that question. One is during this crisis. One is around during this crisis. I categorize the startups in three categories. Right? The first category of startups are looking at survive. I need to my acute hire from that we have, which is join with your competition, right? So like this, that's an opportunity for you to look at. There is another way is what you're going to look at. Can we start looking at second part? So can I survive for 3 to 4 months? And once I've survived, then I can come back to what my original idea. So the third category is about the crisis and opportunity. I will go full swing and I'll grow, like the example of Pradeep I gave, who is growing like 300%. So that's another opportunity, right? So you can't look at that which category you are in, right? If you're a startup that your business today, it's going to be very tough without any of these getting back in action very soon. And it's nothing wrong. You can start looking at repurpose your skill, or you can pivot to adapt, what I call it, or you can just merge with someone. So in one of my startup, Fresh World, we sell vegetable using electric carts, like push cart vending. So our operators go in electric vehicle and they sell, near the apartments. So during the crisis, we were not able to move this and, stand on the street and sell it. So what we have done, we hired a company. This company was selling meat online, but they were struggling. So, but we needed a technology. So we bought this company. So we brought the technology. Our 45 vehicles were not running, but we opened up our hub online and we were able to deliver. So we were able to do the revenue, same thing before COVID, from a completely different model, none of our vehicles running. So this is where, the company who sold is also figured out that that's the best opportunity for me to merge with some other companies so that we both can do very well. Similarly for us as well, that instead of worrying about, okay, I cannot run my 45 vehicles, I'm going to be in trouble, then we quickly looked at what can I do, right, to change this forward. So that is where that pivot to adapt is happened, right? In the normal terms, right, normal time, if things are okay, if your idea is original, right, and if your problem statement is valid, never pivot, right? You keep on working on it, right? I'll give you an example of a company called Unifor. It's an IIT Chennai. So I funded this company like 5 years back. So when I funded this company, he was 5-year-old, right? So what is the problem he was solving? In India, out of 1.3 billion people, only 250 million speaks English. 1 billion people do not speak English. So that's the problem he solved. He went to IIT Chennai, developed a technology to recognize 100 dialects of Indian languages and also 16 Indian languages, right? At 98% accuracy, right? So, and many of the investors said it's not workable, there is no market for this and that. He never gave up because the problem statement is valid, right? After 400 years of British brainwash, only 2 million speaks English. So that's the problem statement he was working on, right? As long as the problem statement is valid, he was believing in himself. He said, this is not going to change next 20 years. This problem is going to be around for a while. I am solving that problem, right? And when I met him, so he was rejected by 25 investors. So that's what I liked him. He said, when 25 people said you are wrong, you never listened to them because you believed in you than some investor telling what to do. So I funded him. Next year, he was recognized by Time magazine in the US. 13 millionaires who are changing the world. Only one person from India, that is Umesh, right? So that Cisco chairman, John Chambers, saw that and he wrote a $10 million check. Today, this company came out of IIT Chennai, has 15 patents with IIT Chennai, competing with the global giants. Speech recognition, right? Who is this competition? Google, Apple, Amazon. And IIT Chennai startup is competing with these companies with billions of dollars of R&D budget. How? He believed in his vision. He believed in the solution that he was working on it. While 5 years, people were telling it not going to work, he was strengthening his business, right? He was listening to 24,000 hours of Indian voice every day. It made the engine so awesome. That's your machine learning. That engine learned very well so that he could compete with Google's technologies, right? If you take Google between US 3 coasts, you have 3 accents. But in India, you go everywhere, any 50 kilometers, you have a different accent, different language, all this possible. That's the diversity he was making his engine stronger. And today he's competing with all the big boys, right? The technology we developed for the Tamil Nadu farmers, it's now helping MetLife insurance company, they helped us people, yeah? So if your problem is original and problem is valid and solution is original, never give up. But we tell others to pivot because, there are a lot of people, they copy an idea. Like, for example, if you say that Ola, right? Ola emulated the Uber model. When Uber started selling idlis, Ola need to sell idli. Doesn't matter whether, what is the link between cab business and the idli business. My competition is doing, I copied from him, I have to do the same thing. So this is the pivot part. If you're copying somebody, and if this person is changing, you need to change. Or if you're in a business that many people are there, and you tried for 3 to 6 months, and it's not working, we advise them to pivot. But the original thinkers, right, who are not copying, people who believe in their own solution, the original solution, problem statement valid, never give up. Yeah, next question.
Thank you, sir. I hope the answers also, very, very enlightening for us, all of us to hear, in fact. So we have the next question from the Students' General Secretary. So he has posed a question like this. How can the students gain the expertise to know the various variables and its dependencies when planning of a startup as a college student? What are the entrepreneur skills that students need to possess to fork into entrepreneurship, if any?
Okay. So I think I'm going to ask a question and you can answer that in the chat box, right? So how many of you can sing? How many of you can sing? You can answer in the chat box. Yeah?
How many of you can sing? Okay, we've got one.
So there is one Shankar singing. Good. So we have around what? 83 people. Yeah, one person responded. So I walk into a first standard classroom. Okay, Gayatri. Gayatri. So we have 2 people out of 80 and sing. So I walk into a first standard classroom. I ask the same question, what happens? How many people will say? Yeah, everyone, right? So this is what happened? We were all gone through the first standard, right? And so why 84 saying, how can I sing? So this is the problem we have. So when you're a 5-year-old, 6-year-old, you never bother that who are you, right? And I used to not start singing a song. So today you'll be wondering that, is he going to ask me some song? Can you mute people who are not talking? That'll be great. Yeah. So there is a mind voice going on, right? In you that he's going to ask me to sing a song. And if in this question, when I ask in an auditorium, you can see that people, pulling down that friend's hand down, that don't make a scene, you're a horrible singer. But all of you are a good bathroom singer, right? So what happened to us? This 30-second when I ask a question, so what went in your mind? It's called voice of judgment. So that prevents you to become a singer, right? And even though you're a good bathroom singer, you don't want to be singing. So next question, ready? I'm going to ask next question. How many people can hear the sunrise? Can you hear the sunrise? Can you hear the sunrise? Just answer in the chat box. Yeah. Channuga Priya, no. Madan says no. There's a lot of no. I thought IIT Palakkad is smart people, yeah. 1, 2, 3, 4, 5, 7 no's have come already. Yeah. Can you hear the sunrise? You are the beautiful place of Kerala. And Palakkad is surrounded by beauty. Yeah. You cannot hear the sunrise. It's a monsoon time, huh? Yeah. Nobody? Oh, yes. All knows, yeah. All knows. Okay. All right. So you can hear the bird chirping in the morning, right? You can see that, okay, the birds are chirping, so it means that sun is going to be up. So what this tells you that if you're waiting for one of your eyesight, the sense to tell you whether sun is up, you're missing out all the other senses. What are they telling you, right? Because we have all the 6 senses and we don't listen to all the 6 senses, right? We have started looking at only 1 sense and then say that sun is not up, right? So when I grew up in our town, morning we'll have water. So people start fighting for water. So we know the sun is up, we need to go stand in the line for water. So this is the point. So what this has to do with entrepreneurship. So these 2 questions that I asked, this has to do with entrepreneurship. The first question I said about how many of you can sing. The second is about the sensitivity. You take a 5-year-old and give her a toy. So what she do with the toy? She will try to break it. She will try to, open it. She will try to put it in her mouth and the mom will tell you it's not edible, right? So she's applying all her 6 senses to figure out what this toy is. So this is called childlike curiosity. We all lost it, right? We used to have it. We've lost it because the more we're growing up, after maybe, 8 standard, I think our question and curiosity level goes down. And now you're a college student, you'll say that this professor is boring. I can ask this question in Coursera, or I can watch a YouTube video. I can learn probably hydraulics. This boring professor is, boring me, right? So we'll think that 5 minutes of these videos will teach us. And so because we are not going deeper on our thought process. So this is where that first thing for an entrepreneur to be is about sensitivity. So if you are sensitive enough, you will listen to all your senses. Who is an entrepreneur, right? When a person sees a problem, somebody calls a problem as a problem, that person is an ordinary citizen, right? A person calls a problem as an opportunity, he's an entrepreneur, right? So when somebody calls X, the whole world calling that as Y, right? You calling something X, the whole world is calling as Y. What the world will call you? They will call you mad, right? Because the whole world is calling Y, you are calling X. So this is where you need to have the strength of a first standard student. You don't bother. Because when you call a problem as an opportunity, when somebody says that, oh, this is a crazy thing, that's a crazy ideas. So when you share your idea to anyone, the more people telling you are wrong, you are in the right track, right? That means that they never thought about that problem as an opportunity. They're just sitting there about, whining, they're cribbing about, oh, in Kerala, just go like this, nothing happens in Kerala, no industries, entrepreneurship doesn't come to Kerala, but Tamil Nadu is different. It's like this, people have excuses all the time. So these are all the people, when they say that you have an idea which is wrong, then you are on the right track. So that is where the first question is important as an entrepreneur. When you tell somebody a problem as an opportunity, when they laugh at you, you have to think like a first year student and start singing a song. Doesn't matter whether ARM on audition you're going to pass or not, right? So you're all very good bathroom singer. We all know Jana Gana Mana. Start singing Jana Gana Mana, right? So that's the kind of gut you need as an entrepreneur, that more people telling you're stupid and you don't listen to them because they have not thought about this as an idea. They thought a problem as problem. You are calling problem as an opportunity. That is where the number one skill to have as an entrepreneur is ability to sing, right? So now you're finding problem, then you're calling that as an opportunity. So now we need to find the problem in the first place, right? So that's where we have a problem. So we are not applying all our senses. The senses are telling problems around us all the time. And we lost the sensitivity because we don't look at things like a childlike curiosity. We look at everything as, oh, I know it, it's boring, professor, yeah, right? Because we don't look at everything as fresh. When you look at everything as fresh, you will know about what everything is telling you, right? And this is where we need the second question answer. You should have an ability to hear the sunrise. So when all the senses are open, you will pick up problems around you. Every problem is an opportunity. Every complaint you make on a daily basis, right? Today is crisis time, there's a different kind of problem, but a normal day, right? There's a water problem, flood problem, corruption problem, politician problem, food problem, vegetable problem, everything. Every complaint you make till morning, till you go to bed. All the complaints is a business plan. So that's what I call India's strength is about PPT, right? Problems, thousands of problems. And we are all technology, you have engineers. Apply the technology. Technology doesn't mean the Bangalore definition of technology. The Bangalore definition of technology is an app. When they tell these guys that there are 400 million people who do not have electricity, they will say that, sir, we will write an app to track all of them, right? So they think that app will solve the world's problem. So in IIT, you are there. So apply whether you're learning civil, chemistry, mechanical, electrical, everything you need to apply into your solution so that it's scalable. So science and technology should be brought into any solution. Even if it is Ayurveda, a chemical engineer should prove it that, yes, we are adding mercury in the process, but the residue doesn't have a mercury. Put an IoT device, put a sensor and say that, here is a Chavan Prasad made in Kerala, doesn't have a mercury residue, and bring science into it. If you say that Dhanvantari God, it's 5,000 year old, nobody's going to buy. So science and technology can come into any part of it. Apply what you're learning Unfortunately, many of the IIT, where I go, all the guys will end up writing some stupid Java code for Infosys. So you need to apply every discipline that you are in, you have to apply. I was in IIT Kharagpur. IIT Kharagpur is the only one has an agriculture engineering, right? 95% of the agricultural engineers are sitting in Infosys writing Java code. They just want IIT tag, right? Doesn't matter what discipline that I am doing. So that's an opportunity you have about going deeper on what you're learning, because we have thousands of problems that require solutions. It can come from you, right? You have an opportunity to it. So that's where you find a problem, you apply technology. If every Indian buys your solution for 1 rupee, you have a $1 billion company, right? So that's the potential that we have. So the skill for an entrepreneur is about ability to sing a song, hear the sunrise, nothing else. No education, no IIT degrees required. We funded a guy in Trichy, the Native Lead Foundation, what we mentioned earlier. We started this NGO to promote rural entrepreneurship. We said no English, no PowerPoint, because 250 million only speaks English. That means that 1 billion people may not have an idea. That does not drive, right? So we said no English, no PowerPoint. You pick a problem, start working on it. We will support you with the local investors so that it doesn't have to go anywhere. So local investors, local entrepreneurs who invest, who mentor them so that they can take the idea. We funded this company called Happy Hands. So this person, Ashok Kannan, never went to school. He's wheelchair bound and the school rejected him. He wanted to go to school. The school did not want him. So he is an Ayurveda expert, right? He was feeding herbals to one of his country chicken. He saw that the egg was in orange color. He was surprised. He sent the egg to the Indian Institute of Science. So a guy never went to school. He's sending the egg to the Indian Institute of Science to tell, hey, why my yolk is orange color. So they told that compared to a broiler egg, your egg has 4 times more nutrients, right? And he looked at the Royal Society of London standard on free range poultry. So 1 acre, 1,000 birds. So he brought the herbal wisdom from Ayurveda and he took the London standard of free range poultry. He merged both. And he came to us with his idea. We were all surprised. A guy never went to school and he's wheelchair bound, come up with this crazy idea about free range poultry with orange color yolk, and we funded him. Today, he's making around 20,000 egg every day. His egg is most expensive egg in the country, right? So he got a call from Google. So why would Google is calling a guy who never went to school selling eggs? So they sell Human Society International certified eggs to their employees. So Happy Hands, since they do free range poultry, they don't torture the animal. They applied for HSI certificate from Europe. HSI is an European, NGO. So HSI, he's one of the few to get HSI certificate in India. So Google came to know about them that he's a guy is getting HSI. So they want 1,000 egg every day for their employees in their Delhi campus. So a guy never went to school, Google calls you, right? So it is all about the problem and the solution. Nothing else is matter, right? Ability to sing a song. Can you hear the sunrise? That's the only skill you require. Yeah, next question.
So we have one more question. How do this will be the last question. For the moment, I think we would not be able to take many questions today, but of course we can definitely interact offline. How do the well-established companies see a startup in the same industry? Are these looked at as innovation banks that the companies would like to invest in, acquire if they perform well, or they do see them as their competitors, even if in a limited sense?
Is there any big corporate in the anybody sponsor program? Okay. Because I'm going to be very, very candid. So number one is about if I'm a corporate and if I'm looking as a startup, so no corporate want to make a startup to grow bigger than them, right? So no corporate would want to make a startup to grow bigger than them, right? So that's number one. So you need to be very careful working with any corporates on. The second is about, yes, you need to be very clear about what is the expectation, right? So, most of the time the big corporates with a lot of R&D budget won't be able to innovate as fast as a startup. So the example I gave, a Chennai-based startup, Unifor, it's competing with all the big guys with $1 billion of R&D budget, right? But how he's able to do it? He's very frugal. He's very nimble. He can think fast. And the CEO of a startup is a chief everything officer, right? He's thinking about he's breathing every day about that problem. He can come up with solution faster, right? So if you're a corporate, and why would they want to work with startup? One is about they can bring this nimbleness back to their company. That's one. The second is about if you're talking, if you're taking an investment from a corporate, and if you're making a product that could be the corporate is the customer, then your customer is investing in you and he bought a product. So then if you are like this, will his competition buy your product, right? So if I assume that there is a retail company called Target in US, right? If Target is investing in you and then they become a customer, will Walmart buy from you, right? So that's the second thing that you need to be thinking about it, is that what kind of a relationship that is. So you need to be careful that is it the same industry as my investor or a different industry. So the third is about be very clear, right? Even if you go with this kind of approach, at some point you'll end up selling your company to that corporate, right? Because that corporate is your major customer and they are your investor. So his competition may not buy or invest in you. So you ended up need to sell back to that corporate. So you have a very clear about what is the arrangement. There is nothing wrong if that is your intent, but it should not be a surprise. But be very clear on that part. The third part is about if the money is coming from corporate CSR, no problem, right? Because it's a CSR budget, they are helping startup, that's no problem. If the corporate it's coming from their other budget, which could be their marketing budget, which could be a R&D budget. So that means that they're expecting a return on it, right? So we are seeing a case that a startup is funded by a corporate, and this corporate ended up pushing the startup to sell their products. So now they are in trouble, they're coming out of the relationship, right? So be very clear if the money is coming from the marketing department or R&D department, there is an expectation, ROI expectation is there. Or is it aligning with your vision? Yeah, so that is something you need to keep in mind. So in US, I always tell that in US, many big companies are killing innovations in the name of higher valuation. You take an example of say Google, the last 20 years, there was zero innovation, right? Everything is bought. YouTube is bought, right? Android is bought, Nest is bought. Everything is bought from some startup and given a very high valuation, and the startup is dead. So now Google got that technology, they are taking it forward. So in many of the US countries, in US, in the name of higher valuation, they kill the innovation by offering a huge valuation. The entrepreneur think that, oh wow, awesome, I got a great valuation, I sell my product, and you sell your dream as well. There is nothing wrong in it, but is that your intent? No regrets later, right? Be clear about what to expect from these deals, right? So that similarly, that if you look at, there is this company called Dropbox in US. They refused to be bought out by Apple. Now today is one of the big companies. It's like this. You need to think about always an opportunity. Can I grow it on my own without that support? Or I need a merger, or I need to sell. It is your call, but no regrets. There's no right or wrong answer, but be very clear that every relationship, who gets what and what is the expectation. Don't thinking that, oh, there's a big brand is coming after me, that I'm top of the world. There's nothing like that. They're finding some cheap innovation from you because their own engineers in R&D budget not innovate, you are innovating faster than them. That's the only angle they're coming. Then other things possible. So you are an IIT, there's a joint innovation programs happening, right? If you go to Indian Institute of Science, you have like 3-4 building with Bosch and Tata Motors. So they're doing joint development, which is different, right? They're investing heavily on the joint research program, and both the organizations will share the royalty, right? That is different. But in a startup, do you have that kind of leverage that you need to think before you go? Recently, I've seen one of our startup. The startup has a fantastic idea. So this one corporate talked to him and they were very happy. Then the corporate said, we will invest in this idea. You take this forward and we will help you to market this product, because this product we are going to launch as a separate product. So after like 3 months of constant back and forth discussion, out of the 3 co-founders, the corporate convinced 2 of their co-founders to join them for a 1 lakh salary, right? And they agreed. And so the one guy, he doesn't want to go with that. They signed a letter with that person. He said, next 5 years, you should not work on this idea. So 3 co-founder, 2 co-founder joined this company for a 1 lakh salary. And that idea is given for free. Right? The company launched the product is a flop, the idea is dead, because they didn't think like an entrepreneur. But whereas this one guy who's left with the company, he cannot work on this idea next 5 years. So now he's working on a different idea. So you'd be very clear about what is the relationship that you are getting into. Yeah. Okay.
I think we don't have any further questions to go ahead, sir. So if there's anything, I'm sure we would be interested in connecting with you offline.
Yeah.
So now we are actually proceeding into a panel discussion. So depending on your availability, you can actually join us, and we would definitely have it as a great honor to have you with us.
No problem. Great. Excellent. Thank you very much for everyone. I messaged my website details. Just reach out, if you have any questions. All the best, and thank you very much. Yeah, you can proceed.
Thank you for bringing in the component of essentiality, I think, into innovation. And the examples that you've brought in is really, really exciting. I think some of the students have also written their feedback directly to you. So it's an honor to have you with us, sir, once again. Thank you so much for your time.
All the best. Yes.
Thank you. Bye. We take a couple of minutes of pause, and I'll just get back to you.
Hello, am I audible? I just want to check.
Yes, Piyush.
Yeah, is it audible?
Yes, audible.
And
Yes.
video is also fine, right?
Yes. Okay. So we are next moving on to the panel discussion, which is the last component of the common session for the day. This panel discussion has been curated around the theme of inculcating entrepreneurship and startup culture at IIT Palakkad. The focus would be on delving upon specific themes on startups with the help of the esteemed moderators that we have and the illustrious panel. As the moderators, we have Dr. Anand TNC, who is an associate professor in mechanical engineering at IIT Palakkad, on transfer from the IIT Madras right now. He has received his PhD from the Indian Institute of Science, Bangalore in 2009. He worked as a postdoctoral research associate at IIC before joining IIT Madras in 2010. His research interests include the application and development of various optical diagnostics techniques. He works on spray and droplet dynamics, evaporation, droplet-droplet interaction, liquid jet atomization, image processing and computational fluid dynamics as applied to IC engines. He is joined by Dr. Vijay Muralidharan, who is an assistant professor in electrical engineering at IIT Palakkad. Dr. Vijay works extensively on robotics research and product development. He is a PhD from IIT Madras, and before joining IIT Palakkad, he was a postdoctoral researcher in Sweden. He later managed product development in a medical device startup based out of Bengaluru. Over to the moderators, Dr. TNC Anand and Dr. Vijay Muralidharan.
Thank you, Soumya. And thank you all for joining us. We're especially grateful to the panelists for being here today. I'll maybe just share my screen before we start off. Just one moment. For some reason, the window I want doesn't seem to be showing up. Okay, and there we are. So we have 4 panelists from industry and 4 panelists from academia from our own institute here today. So let me invite Mr. Vimal Kumar and thank him for joining us here. So he's one of the founder members and the CEO of JustPay. So JustPay, as I understand, focuses on providing an online platform, especially for mobile-based payments. And it was started with the idea of revolutionizing digital payments in India. His interests lie in functional programming techniques, and he's experienced in Haskell and PureScript. He received his BTech, I believe, from the College of Engineering, Kindy, which is a place which I like a lot. And he was also earlier, I believe, the Chief Information Officer for bankbazaar.com, and also served as a tech lead in Amazon and Trilogy. So thank you very much for joining us here.
Thank you. Thank you, Anand.
I think maybe I'll hand it over to Vijay.
Yeah. Okay.
Vijay?
Hello.
Yeah.
Yeah. Okay. Great. Hey guys. Yeah. Good to meet you all, and I'm very glad to be part of this panel. And IIT Palakkad, as I see, is also into functional programming. So that was the great excitement for me to join this event altogether. And it's great to see young people and entrepreneurship. And I would want to also put my speak my mind out regarding my experience maybe with entrepreneurship. Maybe the word itself, what it means, I also question that a lot. Looking forward to being part of this. Yeah, thank you.
We also have Dr. Shantanu Chakravarti with us. He's the co-founder of Mimic, which is a startup incubated at IAC. He's a mechanical engineer by training and has a PhD from IAC. He had his MS from the University of Utah from Salt Lake City earlier. And for his research, he studied haptics and simulation-related issues for developing endoscopy simulators. And I believe the first product from Mimic would be based on an endoscopy simulator. And his interests are in medical devices, haptics, robotics, and virtual reality-based simulation. So thank you again for joining us. If you'd like to share any opening remarks before we go on to the other panelists.
Yeah, nothing specific. Thanks for having me here. Looking forward to learning from everyone. Yeah, thank you.
Thank you. We also have Dr. Bhargav Dave, who is the co-founder and CEO of Vigilean OI, a Finnish startup focusing on solving complex production management problems in construction. He's an experienced researcher and expert on lean management problems and BIM in the construction industry. He has a background in process management and IT for construction and a PhD from the University of Salford. He specialized in process improvement and was a senior researcher at Aalto University in Finland before co-founding Vigilean OI. He has several publications and projects in this area. So thank you again for joining us. If you'd like to
Thank you for inviting me here. Glad to be here. Thank you.
Thank you. And we have Mr. Rajiv Chandrasekaran, who obtained his bachelor's from AESI and then worked at NAL in Bangalore. Then he did his master's in aerospace from IIST in Trivandrum, after which he joined Team Indus, which also competed in the Google Lunar X mission. So he was a part of the spacecraft propulsion group there, and he then co-founded Featherdyne Private Limited, which is incubated in Kerala at the Maker Village at the Kinfra High Tech Park in Kochi. So Featherdyne focuses on making unmanned aerial vehicles, UAVs, and auxiliary systems for various applications, including surveillance, utility monitoring, emergency delivery, and so on. So we are also grateful to have you here, Mr. Rajiv.
Thank you for inviting me.
Incidentally, since you gave the talk in the mechanical engineering, I already heard you in the morning. It was a really interesting talk. I'm sure the others would
Thank you.
Like to hear you too. I request my colleague, Dr. Vijay Muralidharan, to introduce the other panelists.
Welcome, Professor Tom V. Matthew, who is professor. He's a professor with the Department of Civil Engineering at IIT Palakkad. He's an alumnus of College of Engineering Trivandrum and has done his master's and PhD from IIT Madras. So he's an expert in transportation systems engineering, and his doctoral research was on bus transit route network design using genetic algorithm. He has briefly worked with Amanda Software International and has about 20 years of teaching experience. He was a faculty in the Civil Engineering Department at IIT Bombay before joining IIT Palakkad. His current research include traffic flow modeling, simulation, traffic signal control systems, and so on. So I welcome again Professor Matthew. You share some initial remarks.
Yeah, thank you for this invitation, and I'd be happy to contribute my perspective as we go along. Thank you.
Thank you. Next, we have Dr. Ganesh Natarajan. He did his BTech in Mechanical Engineering at IIT Calicut and PhD from Aerospace Engineering at IAC Bangalore. He has also worked as an assistant professor at IIT Guwahati before joining IIT Palakkad as an associate professor. So his primary research interests lie in the field of computational fluid dynamics, focusing on novel computational frameworks for fluid flows, both compressible and incompressible regimes. And he's also been interested in mathematical modeling in sports with an emphasis in cricket. Welcome again, Dr. Ganesh. Do you have any initial remarks?
Yeah, thank you, Dr. Vijay. And I look forward to the panel discussion, and I believe that it will be a very fruitful discussion. So looking forward to it. Nothing more from my side. Thank you for the welcome.
Next, we have Dr. Piyush P. Kuru. He is currently an associate professor at Computer Science Engineering Department at IIT Palakkad. After his BTech from REC, presently known as NIT Calicut, he went on to complete his MSc and PhD from Institute of Mathematical Sciences in Chennai. He was then a faculty at IIT Kanpur, where he was an associate professor in the Computer Science and Engineering Department before coming to IIT Palakkad. So he's a theoretical computer scientist with interests in computational algebra, compilers, functional programming. So he has been with IIT Palakkad since 2017. So welcome again, Dr. Piyush. So do you have any initial comments?
Yeah, thank you for making me part of this panel. I should start by saying that I am probably the least qualified person to be in this panel. So I am probably going to learn a lot from this panel discussion. Thank you.
Right. Of course, everyone is here to learn. So that is, we look forward to it. Yeah. Lastly, we have Dr. Arvind Ajoy. He did his BTech in Electrical Engineering from IIT Madras and PhD as well from IIT Madras. And he was a postdoctoral researcher at Purdue University and then next at the University of Notre Dame and then at Cornell University. So he has had multiple opportunities. And his research interests lie in atomistic computation, circuit designing for RF and high power applications, MEMS for low cost instrumentation. He has also worked at IBM Semiconductor R&D Center at Bangalore and has joined as assistant professor at IIT Palakkad since 2016. Welcome, Dr. Arvind. Any initial thoughts?
Thanks, Vijay, and thanks to all the organizers for inviting me. I look forward to learning from the panel and also giving my inputs on the topic under discussion. Thank you.
So I request my colleague Anand to take it.
Thank you. So before we start, we thought we'd have a little poll to the audience. So I'll request Soumya to maybe launch. So we'll request you to. We'll maybe give 30 seconds for the audience to fill this in so that we have some sense of what the audience thinks. Maybe we'll have another 10 seconds or so. We've had about 60% of the audience who voted so far. Okay, and since we don't seem to be getting any more responses, I'd request Soumya to share the results with everybody.
In polling, right?
Yeah, you can end and you can maybe share the
Yes, okay.
results. So we can see that about 95% of the people here do think that India needs more entrepreneurs. So that's a nice start, and it also sets the tone for why we are here today in this discussion. So we had a couple of questions from people, from faculty and from students. So we have some of them listed here. So we'll maybe start with the first one. Of course, many of these have been addressed in various forms by many of the speakers in the discipline-wise sessions and also by the keynote speakers, but we'd like to get all of your views over here. So we have 3 questions on this slide. It's open to the panelists in any order in which they want to answer them, and we are open to any of the panelists taking up any of the questions first. So over to all of you.
Yeah. Hello?
Yeah, please go ahead.
Yeah. So I just was looking at the questions. So the first question says, do you think startup will become a necessity rather than something that only risk and challenge seekers get engaged to? So I probably want to say something about why universities like IITs and all should think in terms of startups. See, the main point here is that if you look at big companies, right, they usually are status quoists, right, if that is a word. Yeah, so they don't, they have a set business, they probably have a monopoly, and they have probably large cash balance. And so in generally, the case is that they might not innovate, okay, not at the level that you think they would. So for a university, I think the biggest advantage that you get by having tie-ups with startups is that startups have to innovate because they don't have the big money, they don't have the monopoly. They can't follow the litigate but not innovate kind of strategy. So I think for a university, it makes sense to have good relations with startups, and kind of that's probably the only way in which some of our ivory tower ideas can really see the use that we always want our ideas to have. That's my point about why we need startups, at least from the university perspective.
Sure. Maybe Dr. Bhargav on the industry perspective.
Yeah, I would say I would say that that's actually quite true. That I think it's an opportunity for a new IIT to actually have this sort of a culture already from the beginning. It's, I think, not so present in the Indian universities. It's my or rather in India in general, sort of the startup culture is kind of quite missing. It has been highlighted by quite a lot of speakers, that I've heard from today in these sort of various sessions. that we need to breed this innovation culture. We need to breed this sort of problem solving culture, and how do we bring that to the entrepreneurship sort of level. And I do think that startups are kind of a necessity, because we focus on sort of deep problem solving for certain areas. And I think my constant observations, they have been that when Indians go abroad, they do research and they engage with this sort of entrepreneurship activities. Why can't we do that here in India? What are we missing? And I think what's missing is this sort of culture already at the university level. If we have these incubators, if we have opportunities to sort of go out and engage with these sort of activities, then I think people already at a young age will get that sort of mindset. Now, whether they may engage with that already when, for example, if they're doing their bachelor's, it's okay. I mean, if they don't, but they may have the seeds planted in their brain. So when they go out, they look at certain problems, they get passionate about something, they would know where to fall back and start something. And I think that's why I would say that it's quite prudent to think about something like this. I'll just say that I might have to step out for half an hour, and I'll join you back in half an hour. It's a fantastic discussion, but I just have another sort of meeting lined up, but I'll come back. But thanks a lot.
Yeah. Arvind, would you like to comment on this? I think you're muted.
Yeah. So we can answer any of the questions, right? Yeah. So I'd like to give an input on the second point that's been raised regarding IIT Palakkad and similar third generation IITs still trying to find their feet. And is it prudent then to think of producing entrepreneurs? I think it's all the more prudent that the new IITs that are coming up embrace entrepreneurship and innovation, incubation, and entrepreneurship. The three things. Embrace it wholeheartedly. I can talk from a little bit of experience, not as somebody who has started anything, but as somebody who has seen. So when I was an undergrad student at IIT Madras, the Innovation Center there, the Center for Innovation, was just starting. And prior to the Center for Innovation, what was then called a hobby lab was essentially one room with a few benchtop vices and few drilling machines. That's all that was there. In about 5 years, the Center for Innovation really caught on, and a whole lot of companies that today are all the rage, like Ather Energy, Hyperverge. Ather Energy works on electric scooters. Hyperverge does machine learning. They started off as a computer vision club in those days. There's another company called Plansys, which I understand does some kind of underwater reconnaissance vehicles. All of these were essentially started by juniors of mine who came in and just wanted to tinker in the innovation lab. And it's quite amazing how that ecosystem has bootstrapped itself, and today boasts of an excellent and very healthy kind of environment for starting companies. I think India also was going through a transition around that time, and by happenstance or by design, IIT Madras found itself aligned with those things. I guess that for new IITs, there are already these kind of success stories which we can emulate and which we can modify to suit our own ecosystem and constraints. Over the last few years, we have a fairly well-furnished and well-equipped innovation lab here at IIT Palakkad too, and a whole lot of faculty and students, research scholars use it. I think the only thing that we lack really is a critical mass and a few trailblazers who then really encourage others to follow suit. I hope that this kind of panel discussion will kickstart some of our students into becoming these trailblazers. Thanks.
Thanks, Arvind. Maybe we can hear from Mr. Shantanu on this.
Sure. Thanks. So, I mean, I was just thinking about this, and one of the thing I want to like sort of, uh, put forth is, the ecosystem is not just startup or academia. It's together, and there is like there's also the funds, there's government. Everything forms an ecosystem for a country like us. And if you look at, for example, Silicon Valley, which is sort of uh, the looked after place for startups and things like that. It's there because they're like really good universities which collaborate with startups, and the whole idea about of dating back to Intel coming out, and then Freescale, all the Silicon Valley thing coming out with the new gen companies like Apple, and everything started because there was all these universities which was already working. And the role of academia in startup, or sort of just looking at how we can build as a nation. I mean, it's written, so I mean there's nothing to dispute about that. Thinking about whether startup should new IITs be thinking about startup at this point of time. So I mean, as others pointed out, definitely yes. More so it's important because when we are starting young, it's very important to get that culture into it. And build from there, and it takes time. For example, the US universities which we look up to have like at least 100 years experience and things like that. So when we start early, it really helps to bring that culture into thing. And startup or entrepreneur culture need not necessarily mean that the student goes and then after graduating he just there's a big startup coming out of it. It's a way of thinking, of building things, looking at products and from a holistic perspective, which is helpful for even industries or general in society in general. So I feel like it's very important. Yeah.
Thank you. Maybe we can hear from Mr. Vimal.
Yeah, sure. So, see, maybe I will talk about my experience. See, I didn't get into the startup bandwagon the way in which maybe the entrepreneurship is portrayed as, there is a playbook for like starting a company and like raising money and like going to the next step. Well, there is that part which outside the internet keeps talking about. Ideally, I wanted to get into science. I wanted a bit of independence to do things, and always, looked at the big picture and wanted to solve something meaningful, and see, to keep it short, right? I think when you start a company, you get fully immersed in it with all your full self and all that you have, all the skills that you have, bond, nurture, everything, right? Everything you have to put into, to the front line, because as much as it seems like, people will like you go to a school, teacher is going to teach you and you will get better and you'll get marks. I don't think at least the startup ecosystem is like that. Okay, you start a company and like people are going to help you with everything, right? It is a war. That's what I've seen. War, you can say war at a problem, right? You have to, is it about risk taking? Is it about, see, what's the big deal about risk taking? Once you have, I think, the holistic mindset that Shantanu talked about, which is like the big picture. So once you have big picture and you are committed to something that you want to solve it, and it is, you can even see it as it's greater than yourself, whatever it is, whether it's a startup or whatever form it is, with which you can solve it, that will find you, right? And each startup is also different. If you are passionate, and if you find something meaningful that you want to do, and there is going to be pain involved also, and what you want to do is it's something more than that, right? I think then you get into it. It's not going to be a easy thing. And well, why it's not easy is like from my experience. Again, maybe there are different types of startups. If you take internet startups, etc., there is, unless you get big, you are not going to be there. So you'll get consumed, and there is always going to be all kinds of fights that you have to go through to, because in the early times, there used to be a lot of distribution in terms of space. Like there can be like a city can have the largest one business which will serve that city. But like right now, you can't be at that level. You have to be at a country level or you have to be at international level. And there can't be a lot of companies at that level. So if you are getting into something, there is going to be like a lot of pressure for, to get big and to, and you have to keep finding your niche otherwise, right? And to do that, there is constant innovation required. You have to keep coming up with ideas, and how do you put up with all that, right? So I think that's the thing. Startup, like sometimes I see that people get into startup with that understanding that, okay, maybe startup is an interesting thing. I don't want to do other things. Maybe startup is the way, right? Rather, if you want to solve a problem and that turns out to be a startup, that's great. And if you want to be independent and for that you want to put that fight, you will find a way. And yes, it's see, in that regard, the ecosystem also has to help. I totally agree with that. But at the same time, what I've gone through, my personal journey, is that you will discover the potential in yourself. I'm still going through it after all this experience, and that's something that doesn't need to happen much later in your life. That can happen earlier, and that happening is something which is not easy also. And well, for that, you want to jump into the water and swim back. Well, if you want to do that early, do that. I don't think there is it's not that risky. It's not like people used to go for wars and all before. This is like much easier than that. And one more point. I think a lot of people here are into research. It's amazing how that's a constant interest for me, how to bridge research and practicality, right? And if you are even if you are interested in such a concept that you want to do, I want to take this research and I want to put it to practice, and you will somehow do it, right? I think that kind of willpower and all would have to be required for you to cross all these all these hurdles which come up. But it's worth it. Yeah.
Thank you. I'll maybe ask Mr. Rajiv to comment on the third question. Do you think it is all right for young students with no prior experience to try out startups, and how do they get up to speed quickly?
Yeah. So actually, the answer to the third question, how to bridge the gap, is an answer to the second one. So you should actually, it's very important for IITs, something like IITs, where you make a lot of technical people to know what is, to teach them or train them for knowing them what is entrepreneurship. So I'll just quote Mr. Sandip Tandaseri, who is the CEO of Aditya Ferries, which is a company there in Cochin. So what he says is that we engineers are guilty of one thing, that we make something, we invent something and then try to find an application for that. And this is one of the major reasons why a lot of startups actually fail. If you look at a lot of startups from with founders with a lot of very good technical background, they fail because of this. One of the main reasons is this. So first of all, we should teach our technical people how to find out problems that are relevant for the society, for the nation, and then make them. They can easily, once they know the problem, they can easily solve them out. Yeah. So that is my view about the second and the third question.
Okay, thank you. What we'll maybe do is what we would like to also discuss is, what do all of you think are the necessary ingredients for having an ecosystem of innovation, entrepreneurship, and startup within IIT Palakkad? Maybe I'll request Professor Tom to start off on this, because incidentally, as far as physical infrastructure goes, he also heads our EWRE, which does this. Professor Tom?
Yeah, I'm sorry, I forgot to unmute my mic. Yeah, so thanks. And yeah, so yeah, first of all, I think from my experience, like back in IIT Mumbai, a couple of things. One is, yes, there is an element of risk involved in going for startups and entrepreneurships. Nevertheless, the young minds are really long for these kind of activities. I recall one thing that I was also heading the placements for IIT Bombay for quite some time. And there we have a policy that if a student wanted to go for an entrepreneurship startup or something like that, he can take a defer in his placement. He can come back after 2 years. And so in the 4 years I handled, we have given about 40-50 students this kind of exemptions with the condition that if they want, they can come back after 2 years for placements. And interestingly, in my whole term, none of them came back. So that means there is a good amount of students who are interested in taking this. That is one. Second, and they are happy with the decision that they have taken because they hardly anybody came back say that okay, my startup experiment is a failure. I wanted to switch back to some kind of job. So that did not happen. So that means actually there is the students are very interested in startup career and are willing to take risk. So that is one thing. Second thing is like from from a faculty point of view, there are successful startup people are there. I have seen some of them. However, to an average faculty, this is something that is not in the thing because initially that we are being put in a mold that our career growth and things like that really depends upon publications, and most faculty have gone into that kind of mindset, and by the time they reach the top, I think the prime time for the prime time to take up startups are when we are young. So I think from an institute point of view, there should be, I think one of the recommendations that we can put forward based on this panel discussion, one to our institute is that okay, there should be some clear incentive to faculty who are taking for startups and things like that, because the success rate can be, there can be failures. So the institute have policies that will promote these kind of things. When I say policy, I'm not speaking about the space or funding. That's not a real issue. The real issue is on career point of view. There should be policies that will, simple instance like giving a weightage for startup, things like that. So that is my second observations on this thing. And thirdly, that I really commend my colleagues for this panel discussion. And I think we should not limit this with a talk in a year, but I think there should be followed up with concrete actions so that we will develop a mindset within the campus that startup ownership are viable options. And I'm sure like there are students who they all come with very good JE rankings and so on, but not all of them are really of same mold. Of course, some will go for higher studies, some will go for typical public sector, but there is a cream will be willing to entertain startup. So there should be like courses, programs, and continual mentorship. For that, I think industry is something that can really help us in this area. So that to what I call it as a develop a mindset or a culture of startups and entrepreneurship. That is something that as an institute can do that. Because the benefit of this is, I think, something that is far richer. When people think about startups, we think about some companies and then the monetary gain that comes and so on, etc. But I think more than that, when we as an institute, when we look into students, the students are very young when they come to the campus, like they're just 18 years old actually, and they do not know what is their real strength and their real talent. And as an institute, that we should have avenues for different kind of students. Like we cannot expect all students to be a startup kind of thing. Maybe 5%, maybe 2%, that is sufficient. But I think there should be an avenue for them to develop that skills and mentors. And even if they come up with an idea, there should be someone to guide them and encourage them. So that is from an institute to the students' perspective. Second, from institute perspective, this will really take the institute to a greater level. And after all, again, from institute point of view, that there are many parameters to evaluate the growth and ranking of an institute in terms of publications and so on. But I think this also is something that is a very, very important indicator of the growth of an institute. So from institute point of view, I think also should encourage and have policies and avenues for startups. And lastly, not only from individual student or faculty perspective or from institute perspective, but also from our country's growth, I think startup is a very real boost actually. In fact, we all know about the success stories of startups in Silicon Valley and then later in Israel and places like that. They all agree upon this. The startups, there are some failures are there, no doubt about that. But from a macro perspective, the startups are really going to boost the economy of the region or of the country. So we have also a commitment to our nation building, and this is one direct way that we can achieve that goal. So these are my perspectives on this topic. Yeah.
Sure. Thank you, Professor Tom. I'll maybe request Dr. Ganesh to add in any thoughts on this.
Yeah, thanks, Dr. Anand. Okay, just a few thoughts here. So as far as an ecosystem is concerned, I believe that one of the primary requirements is that people who try to go for entrepreneurship or startup should be very passionate about their ideas, and they should not have the fear of failure. And that's something that prevents many people from actually trying to go for a startup, even though they have an idea in mind. That's one of the points that I want to emphasize on. And as far as the technical aspect is concerned, I believe any institute, whether it's IIT Palakkad or even existing institutes, established institutes, one common point that I believe is a necessary ingredient is probably interdisciplinarity, wherein you need to have exposure to more than one subjects rather than being sticking on to just one core area. Of course, you need a core area of expertise, but you need to probably even have a hands-on experience in several related areas as well. So I believe interdisciplinarity is essentially a very important ingredient, particularly in most startups. And the curriculum as well should probably be molded in some way to inculcate the idea of interdisciplinary courses and more hands-on courses. I think in IIT Palakkad, we have this open-ended lab projects which began last year. So that's a very good initiative in my personal opinion, so that there are students who can come forward, pitch in their ideas, and because it's open-ended, they can fearlessly try working out whatever ideas they have. Yeah.
Can we request the non-speakers to please mute their mic? The non-speakers may kindly mute their mic. Yeah, sure.
Yeah, sure. Thank you. So I believe that's a very good initiative from the side of our institute, so that students get more hands-on experience. Plus, well, the students do go for Indian companies and organizations during the summer holidays. I believe that that's also a very key point. wherein their experience working with startups during the summer holidays as an intern would actually inculcate a sort of um, uh, confidence, so that when they come back to the institute, the confidence is slightly boosted up. And as an infrastructure, the institute should provide the students with lab facilities. I think my colleague Dr. Arvind had spoken about the laboratories at, I mean, the Fab Lab at IIT Madras that further led to startups down the line. And we also have a C Square lab here. So that's essentially a good initiative, so that at least students can, during their tenure here, they can work out their ideas that they have, participate in hackathons. I believe that we have had quite a good number of students participating in these competitions. I believe only these would, over a course of time, create an ecosystem that would promote entrepreneurship and startup. Another point that I wanted to make was the fact that we have a Kerala Startup Mission, and we do have Mr. Rajiv, who is the CEO of one of the companies incubated over there. Probably Rajiv could probably tell us more about how collaboration with Kerala Startup Mission and IIT Palakkad could help us out. And as Ms. Anuradha pointed out, there was this STIC, that's the Startup and Technology Innovation Incubation Center that we are planning to start, as Professor Sunil pointed out as well. So that's it from my side. But I believe that one point that we should always try to focus on is the idea of frugal innovation. Not just innovate for the sake of innovating, probably be very smart at innovating, something like a smart or frugal innovation, because we do talk about a lot of people who have met with success starting up their ventures, but we largely don't talk about people who have failed at this. For instance, we had this, if I remember, during my student days, around 10 to 12 years back, there was this a company called Guruji, which was touted as a Indian competitor to Google. It was a search engine, but really down the line, 2-3 years later, it never went anywhere. So we should actually be doing a lot of case studies as to why or how certain startups, which started off with a bang, really never ended up anywhere. And if you do look up at the startup industry, I believe it's only a very small percentage of the total number of startups who actually make it to the top, of which we actually hear about. So, well, so we only if we do a postmortem of what went wrong in these cases, would essentially help us in not only evolving an ecosystem where we can have entrepreneurships and startups, but also have more successful startup companies being incubated out of the institute. So that's all from my side there.
Sure. Thank you, Ganesh.
Thanks, Dr. Ganesh. So we'll have another quick poll, after which we'll take some quick questions. So this is more for the students. So encourage the students to actually mention their choice. Maybe another 10-15 seconds. I encourage the students to vote in the poll. Of course, it's not going to be graded. You are free to vote. And it's anonymous as well. Okay, maybe we can publish the result. around 76% of students now would foresee them to being an entrepreneur, and around 25% have straightforwardly said no. So maybe we'll see as the panel progresses. What would you This is a more of thought process for your future. So let's look at the next set of questions. Maybe we would have quick answers for this. So maybe one from industry and one from academia and so on. So Mr. Vimal, would you be interested in taking the first one?
Sure. So the difference between life career of an entrepreneur and that of an employee. Okay. See, I would say that if a company is giving the big picture and the challenges, there is a lot of overlap between the lifestyle of an entrepreneur and an employee. So it could look like maybe an employee could be like very constraining, comparatively closed, like more constrained, and an entrepreneur could be more open. But the other side is also true. It's not like we can do whatever we want if you're an entrepreneur. We are always after customers' needs, resource constraints, like maybe if we have taken money, we need to multiply it for the investor. We work under these constraints. At the same time, we are always looking for jumps. Being an employee, see, I've been both, and there are a lot of part of mine which used to be like like the passion for technology. Before and after, both are the same. Well, one big difference working for a larger company, and actually I was working for a startup before, and that's when like I was an employee in a startup, like a senior employee. So I think at that time I got into the situation of major decisions have to be taken by myself, and that was a big difference between working for a larger company and a smaller company or your own company. So because there is nobody else to take that decision, whether you want to host in which data center, what servers to buy, what language to choose, everything is open, and the decisions that you take, nobody else is gonna validate it, or you are responsible for it. I think that is a big difference that I saw being an entrepreneur. Like a lot of decisions to take, and you have to stand by the decisions. You have to somehow make it work, or you have to change it, or you have to be responsible for your decisions. And well, that be also be taken as an employee? See, we can ask like that also works a lot of times if the company that you are working for is open to that. But typically, being an entrepreneur, there is a bit of more flexibility to take decisions. That's something that I see, but at the same time, not too much. Like if you take a technology choice, and like if people find it risky, your people whom you work with find it risky, they are also going to be like against it, and you have to there are constraints there also. So I think the other side is it's up to us. Like if you want to work hard in a company, or being an entrepreneur, like, see, I know people who create a lot of value by being inside a company, as not as entrepreneurs, much more value than myself. So I think that should not be of much of a difference. The holistic picture and the customer centricity is, in certain dimensions, it's high as an entrepreneur, especially in terms of where is the market going, etc. Entrepreneurship, I see that a lot of times, especially early stages in your company, you have to work on immediate needs. So whether we like it or not, that's the thing, because we are surviving. So another thing, correct. So the survival mindset is much higher required, as from my experience, I can see in entrepreneurship. And after a point, we need to change the survival mindset into like a, like a larger vision mindset. Like, see, we always start with a larger vision mindset, but we will discover that even to survive, it's difficult. So all of these are, I would say, life learnings, being an entrepreneur. Yeah.
Thank you, Mr. Vimal. I think maybe the second question has been answered as well. So I would request Dr. Arvind, if you can take the fourth question. Would you be interested? So who should take entrepreneurship and who should stay away from it?
That's an interesting question. So I have actually seen all kinds of students swing towards entrepreneurship. I have friends who were highly academically oriented, went to the US, either started and finished their masters or finished their PhD and then took to entrepreneurship. I've also seen students who right at the outset were very clear that they wanted to start a company, and they used their entire 4 or 5 years as undergraduates to basically mold themselves, to use the facilities and the networks that were available, and to kickstart their own project. So I don't really think there is any clear answer as to what kind of person or student should ideally take up entrepreneurship. And just as Professor Tom was mentioning, I think these days, and maybe Anand may be able to also add from his experience at IIT Madras, a lot of young faculty of our generation in places that have this ecosystem are also entrepreneurs by the side, right? They have their own companies. And it's likely that many of them who got into faculty positions when they were actually making those choices of going for higher studies and all of that did not actively think about getting into, and starting a company. But then when they find that there is an idea that is developed in the lab, which can then be commercialized, I think they find a good opportunity for that. Maybe Anand or can add to that.
Yeah, it does happen quite a bit. Yeah.
Thanks, Dr. Arvind. May I request Mr. Rajiv, if you can take the last but one question, what are different roles does the founder play in their own startup, and until what point would they engage in product development directly?
Yeah. I can say that I can say something from my own experience that this is a little bit of a tricky question. Ideally speaking, a startup should have a technical founder as well as a founder who's a little bit business oriented, but that may not always happen. And just as in our case, after a certain point of time, the founder has to look back outside. That means away from the product development thing. So the time span for this directly, the founder to be directly engaged in a product development thing is like till you get your prototype done. And after that, and just before that, he should be starting to look at figuring out who is the customer, trying to engage with them, and trying for a validation, like utilizing the MVP and directly validating whether your prototype is good for the customer or not. That is what is ideally to be done. If you don't have a founder who is a technical person and a founder who is a business side oriented person. Yeah.
Thank you very much, Rajiv. Dr. Bhargav, would you be able to take the last question of this slide? Any advice to students on managing personal time and finances? Dr. Bhargav, are you able to hear us?
Sorry. What was the question again? Sorry.
Do you have any advice to students on managing personal finances and time in a startup journey?
All right. Personal finances and time in the startup journey. It's a tricky one. I think every startup journey is different because, for example, I can give you my own example, which might be completely different from the other founders who are here. We actually got incubated initially from the university. So at that time, my salary was, for example, coming from the university itself. So the personal finances were managed reasonably well. I mean, I was a senior researcher by then. But after that, we went into a bootstrapping mode for a couple of years. So I've seen the bootstrapping side of things as well, which is quite sort of interesting. And I think at that time you have to manage your finances extremely well, not just the company finances, but your personal finances as well. And for me, luckily, I was still being a researcher, being a university-backed startup. I had an agreement with the university that I could do both things, and I could manage it that way. But for example, I have had friends who have been working in a funded startup. You go out and immediately find funding from a VC or an angel. And in that case, you can be taking salary from your own startup, and you can be managing finances as well. In terms of time, this is what they say is true, that this is almost like a 24/7 journey. I mean, I know that it's an exaggeration, but you pretty much, you will be devoting a lot of time to your startup. And from that perspective, I think you need to be sure that you want to do this, because before you know it, you might have given, sometimes months, if not years, to a startup, and you might realize if it's not going anywhere, you feel that you wasted that time. Although the previous speaker I was talking, I was listening to, said that, every failure counts, and I think that's also an interesting thing. But yeah, in terms of time management, I think it's quite sort of important to manage that.
Thank you, Dr. Bhargav. Dr. Shantanu, would you be interested in taking the third question? So, what attitude and skills should the students inculcate to start on their entrepreneurship journey?
Sure. So in terms of attitude, so again, so it's all about holistic view, right? So the first thing is we talked about problem and solving it and things like that. So looking from the problem perspective, I think that's very important thing. And the second thing is, I guess if you're coming from IITs or for research institutes, and the idea is to go into sort of a deep tech startup where tech is the core thing, and building is something that will be very key. So sort of doing projects, that having that mindset of building things, putting things together, hacking prototype, so that becomes like really, really important. So so that's pretty much it, I guess. So having the mindset to build things, having the mindset to look from a bigger perspective, and solving problems which are existing out there, and probably also looking at how you can monetize by solving somebody's problem. I guess if you're really solving somebody's problem, monetization is not not a problem. And when I talked about projects and doing building things, it also comes with getting in the team. It's usually it's not one person job, so how to build together, so that also becomes important. So yeah, these things really matter when you want to start up.
Thanks a lot, Dr. Shantanu. I think we'll end our panel discussion here. Thanks everyone. Thanks to all the panel members, for answering these questions and giving a lot of insight. On to Soumya for the next event.
Thank you.
Thank you, Dr. Anand and Dr. Vijay, and also all the panelists who've been able to join us. Thank you so much.
Thank you for inviting us.
Thank you very much.
Thank you. Thank you all.
And we must also thank you for this energizing discussion, which indeed ensured absolute justice to the theme. I'm sure this has truly meant a lot to the participants, and we are one step closer to achieving the vision of the conclave. It is no wonder then that transformational thought and action often take root on such kind of productive exchanges. Moving beyond conventional solution definitely takes a lot of grit and determination, and I'm sure all of the panelists have ensured that our people have it in them and are very positive about what they want to do in their future at the end of the discussion. Platforms like these will enable our individuals to definitely get engaged, to also listen and to speak where the value of an idea is discussed and debated. So with this note, we have reached the conclusion of the common event. At the outset, it gives me great honor and pride to thank each of the participants for their absolutely limited resource, their invaluable time. We express a sincere gratitude to the industry delegates in making this event meaningful through your presence, exchange, and patronage. I thank our director, Professor P.V. Sunil Kumar, and both the keynote speakers who are able to churn our thoughts in innumerous directions. I thank the extremely patient and always welcoming Dr. Sohan Laldas and Dr. Shantakumar for being the backbone of this program. I thank my colleague, Mr. Santosh Kumar R., the Training and Placement Officer, as well as the Student Placement Coordinators for working so hard towards the fruition of this event. I thank all the faculty coordinators for engaging with the delegates and designing the discipline-wise sessions. A special thanks to the CFET team who have chipped in at the right moment to bring the technology in place and we have a seamless experience for everyone. I thank all the students for their presence, engagement and participation. Lastly, I thank each and everyone who have been working tirelessly to make this event a grand success. Here we close the common sessions. This is Soumya signing off and wishing you all good luck for your future endeavors. Thank you and please return to the discipline-wise sessions. There would not be any further closing remarks after this. All of you please have a very pleasant evening. Thank you.